Good to see you here. So today it's condensed training of what we do about MISP. The thing is, today we are not so much people, so if you want to shout at some point, tell that you want more information about a specific topic or explain a problem that you encounter and so on, feel free. So it's not don't listen to us carefully. Sometimes if you have to just shout an idea or a problem that you have. Usually why we do this training is basically to get feedback from users or new users with new ideas. So it's something pop-ups, it's good for us. And usually after each training sessions, our metric is basically the number of issues that you open after. So if we open 4, 5, 6, 7 issues, it means that the training was good, meaning that we get a lot of interactions. Usually I start with something that is a very quick introduction of what we do in MISP and what is our view and how we do the development, because we are a bit different than the other systems that are using information sharing. And I explain the background behind, which might be very interesting on how we do it. So today the idea is the following for the agenda. If we skip a bit, it's fine. It's just that we know where we want to go, but I want to go to the introduction, the generic overview. Then we go to user perspective. Usually we have a full-blown day with user perspective because we have administration too and so on. But today we won't talk about administrations. If at some point you have a specific question regarding administrations, like synchronization problem and so on, just tell us and we can have a look at it, but we won't go into detail in this one because it's quite exhaustive and it might take some time. For us, we wanted to have a look at Viper too, so as I know that some people here are doing reversing regularly, they don't want to basically leave their working environment, so Viper is one way to remain in your infrastructure and so on as a reverser using your terminal and not going to a web terminal. Then we will go more into the contribution aspect where we can extend MISP and do new things with it, starting with simple things that are already very handy, like taxonomies and warning lists. And then the modules appear recently, but it's growing slowly to quite a flexible approach. And then we will end up with the MISP API and some research project that we are working on, which is a MISP workbench, which is a new workbench using this data to do malware classification and so on. It's more kind of research perspective, but at some point we want to integrate it back into MISP. Thank you. Just for your history behind MISP, and I think it's quite important to know the history because it's how we basically designed MISP. In 2012, we had one of the malware working group in Brussels where various groups and CERT were going together to do analysis of malware, discussing what they were doing and so on. And we were basically discovering something which was kind of a pity. The groups was basically working on the same malware for the past 2 months without knowing that each other were working on the same malware. And that was kind of, for us, a disaster because we have the capabilities to do certain software, create our own tools and so on. We were a bit clever, but at the end we were not so clever because we were not able to share. And that was basically where everything started. And then at that time, Christophe van der Pla presented a software called CyberDefSec, which was the first version of MISP during that workshop. And then we started to say, okay, we should invest more time into the development of this because it will save time for us to not do the reversing 2 times the same malware. And then we can benefit quickly from the indicator sharing. So really the work of MISP is based on real use case. So we have no wonderful, incredible plans. We just have problems that we want to solve and we try to have use case around it. That's it, nothing magical behind. And then at the end, MISP itself grows because we get more and more feedback from users, and those users give us interesting feedbacks. That's like we do for the workshop, is we get feedback, and then the project is basically community driven. So you get feedback from users, and the community has decided what we want to implement. And that's why the roadmaps are basically disappearing from the project itself, because we think that it's better to get feedback from users and see what they really want than to make really long-term roadmaps that are blocking us for incorporating new stuff. So the feedback is coming from various different use cases. If we take all use cases as circle, we came from that area, so malware reversing and security analysis. So that means basically our role was to share indicator samples of things that we were doing on our side, malware reversing and so on, And basically, when we do the analysis, we wanted to share those indicators that you can do detection. That was basically the initial use case of this. And then things were going a bit faster because more people were using it, because they saw a lot of data within MISP that we are operating. And then some people were coming and saying, that's great, guys, but we need to use this information to, for example, do track down over grocery groups and so on. And more people were using that in that way. So meaning that you might have sometimes different way of using a platform. So we end up into sometimes conflictual part, and that's part of the games. Yeah. Sometimes you have platforms with some user interface design that are for malware reversal, so very simple, and then on the other hand, the intelligent analysts have much more requirement regarding the user interface. So that's why our interface is basically irritating from that part, which is more simple, but we have some plan to improve it without going too much into something that is too much overly complicated. Some recent use case that we had is, for example, law enforcement. There are some interesting cases. We had one police from a country in Europe who were using already data from us to bootstrap their analysis. The problem they have is the following. When the police is going to a specific place, they seize equipment, so they seize many equipment from a case, and then sometimes they do analysis, but they forget about the core analysis of the systems, like is the system already infected or not. And law enforcement was really interested to get a bootstrap indicators to validate what they seize as equipment to see if the machine is already infected. The reason behind is if you go to a judge and you have a case and you didn't know that your machine was already infected and the opposite party tell the judge that they were infected, they end up into difficult problem. So they will prefer to basically analyze the machine before to find the infection, then they start to work on the real forensic analysis. And so using this for them was basically a way to gather information, bootstrap their analysis, and then do their case. Then we had a very interesting use case where people were saying like, okay, it's great that you get more and more information. I will show you some example in MISP with real platforms. But for example, what we get is a lot of data at regular intervals. So it means that you get information with timestamp and so on. So you can even predict sometimes kind of malware that will grow. So for example, ransomware, we see that in the past 2 years in MISP, it was like an edge case, and it was growing and growing and growing. But if you look in the past, you can see that you can basically detect what kind of trend. So some people are currently looking at MISP, how to use the data set to predict or potentially see the futures of kind of malware or threat that could target them. And a recent one too is more the banking sectors. Banking sectors, for example, you might know the Dridex cases. Those guys were doing quite a nice job because they were well integrated, infected machines, having teams that are basically doing and well known using some banking systems, business banking systems. But the problem that we have seen is basically you have fraud analysts that are sharing, for example, a mule account, so the account that they use for doing the cash out, so to extract the money after the criminal activities on the machines. But you have on the other hand the people that are doing the malware analysis. So you have fraud indicators and malware indicators. So that's why in 2.4 we extended in MISP the indicators to support bank account and so on. So like that you have cases that you can mix support for malware reversal and at the same time the fraud analyst. But this is quite nice. You have many users, but all those users have different use cases. And that's the other problems. If you have different users, they have different purpose of using the platforms. And you see that that's another conflictual problem. Basically, you have three kinds of objective. You can sometimes have subgroup of objective or partial, but one is basically detection, one is to block, or to perform intelligence. The detection, one is basically our most common use case. We want to detect if something is infected, or we want to see suspicious activity, and where we want to dig more formal information. Which is quite fine. I mean, you share indicators, you might have some false positive, but you live with it, it's fine. But on the other hand, you have other users, like, for example, internet service provider, that get indicators, but what they want to do is to block things. But if you have, I don't know, 5% false positive in the data set, that means they block 5% of websites that are legitimate and fine, which is for them a bigger issue, because basically you have users complaining and so on. So you see that we have already two kinds of users that might have conflictual objectives. Then we have other people that basically doesn't really care about the false positive rate that you get, because what they want to get as much information to validate the information. So they want to cross-check information, they want duplicate information. And this is quite interesting because you basically have those kind of use case, and people might complain on one use case against the other use case. So we try to accommodate that into the MISP platforms, but it's challenging. That's, I think, the most challenging part that we have nowadays with MISP, is basically that if people are using the dataset that you have, they might fall in one of the categories, and then you might have different results depending on the data quality and so on. If you want to, thank you. Another thing that you should not underestimate, if some people here already install MISP and deploy information sharing, they might know the issues. If you start to be in the information sharing business, you see that you will have more and more difficulties, but the major one is not really a technical one, it's basically a social measure, it's social interaction. When you exchange information with someone, usually basically you look at someone and you say that I can exchange information to someone because I trust him or I trust her, which makes sense. And this difficulty is very important because when you design software, software should not, override the social interaction. Social interaction is the most important part because you want to validate your relationship with the people and so on. But on the other hand, you might have additional restrictions that are sometimes real and concrete, and some that are just basically unreal or not really existing. One of the most common ones that you have seen with information sharing is the legal restrictions. Some people might complain that, oh, you are not allowed to share information. Which might be valid, but sometimes for information sharing and cybersecurity especially, it's even the opposite. If you discover something, you better have to share it than not sharing it. As an example, if you look at the new GDPR policies, regulations at European level, you have a framework to share cybersecurity events to protect infrastructures. And if you don't protect your infrastructure by sharing the information, you basically are not following what the rules are telling you to do. So even for legal restrictions, sometimes it's the opposite, if you don't do information sharing. So it's depending on your lawyers, your legal advisor, what is proposing to you. Just carefully check, maybe you have an opposite laws or a regulation that requires you to share information. Some valid point, for example, risk of information leak. For example, for the financial sector is one of the most critical one. Circle is based in Luxembourg, so we have a lot of banks, financial operators, and so on. And one of the issues is basically they want to share, but they don't want to share under their name. And I will explain what we do for avoiding these problems. But it's a very good point. It's basically reputation is still very important for some people, so they want to, for example, delegate the publication. And then we have additional kind of restriction, like we don't have information to share and so on. But those ones are just like, I would say, kind of a site restriction, because if you look carefully at what those kind of restrictions, it's not really true. If you do information security, in any case you have information to share. Not information at this, but you can, for example, validate information. Look, if for example, you have firewalls with blacklist from the vendors within your firewalls. At some point, you might have the problem that you have some false positive. So you need to contact your vendors to tell them, oh, this entry is incorrect and this one is a false positive. So you basically share information with your vendor to tell him that this kind of information is incorrect. And that's a very interesting part. In MISP, we have the same, exactly, we can propose change. So sharing information is not only sharing the information at this, but it could be validating the information, qualifying the information, or even, for example, say the citing so that you have seen the information. So you have many cases of many ways of sharing information, and it is not only the fact of sharing the information at this. Another thing that we have seen is we don't have time to process or contribute indicators. I have an interesting story that we had in Luxembourg. It's a bank. They have really a very small staff. So they just have 2 people. It's a large bank, but for security they are really small. So they don't have any capabilities of reversing, or forensic analysis and so on. So for them it's like, information sharing platform is not really useful for us. Okay, so we show them the platforms and they were not really eager to use it. But one day, there's an interesting case. They receive an update to a backend system from mainframe, and they find the update very suspicious, but they didn't know what to do with it. And I know there's this moment of cleverness where they say, maybe we should put these files on MISP and see what's going on. Then they put the file on MISP and they just say, okay, do you know what is it? And then on MISP you have plenty of reversers, and the thing that reversers are looking for is samples. Someone just jumped on it and was like, whoa, what's that? Then they look into it and there was basically a Trojan versions of a well-known financial banking systems. So it was very interesting. So basically, sharing information is not, don't have to wait for doing an analysis. You can already share information about things that you don't know. That you have a trusted group of users, you just throw away the information and maybe something will happen out of it. Now they start to use it more and more, the platform, because they discover that the capabilities that they don't have is maybe somewhere else, and they can rely on it for free. So it was quite a good move. And at the end, the guy that did the analysis was very happy because he did a public report about it. So everyone was happy with it. Same with classifications. Classification can be different. We'll go into detail about this, but the taxonomies, for example, was a way to solve this kind of problem. This one is quite interesting too, because in the past years we had a lot of common, like we have basically a data store that is custom. So that means our data storage is a very simple model. András will do a quick overview of its inside. But this one is not tied to any specific format. It's not tied to what Suricata thinks, it's not tied to Snort, it's not tied to OpenIOC, it's not tied to Sticks and so on. And we have seen that this move at the early beginning was quite a good move, because if you know nowadays the standard, even Sticks moved to version 1 to the future version 2 was the model completely changed, and you have more format there. So for us it was very important to not be tied to a specific format, but that people can put data and then use it for various things. So just to, because the project grows, so initially the project was really small, it was just a core software, and then now you have plenty of other projects. So basically you have MISP, which is a core project. So if you go on GitHub, you have the MISP project, and then you have a sub-project called MISP, which is a core project. It's a mixed infrastructure, so it's PHP and Python, as backend using MySQL, and this one is providing the core API and the core user interface. Then we wanted to extend it. So we introduced modules, we will explain later on what it is, but basically you can write in Python module to interact with MISP without touching the core of MISP. Either import, export, or you have enrichment modules that you can call. So for example, expansion to various total, expansions to passive total, and so on. Then you have other things that are separated from MISP called taxonomies. And those ones are description of classification and categories that you can use for global tagging within MISP. The nice thing with it is you can share with your partners your taxonomy, or you can use your own internally. Right now there are more than 35 taxonomies. It's simple JSON files, everyone can create it. You have national classification, you have classification for cybersecurity even, and so on. And it's really bound to your organization. The nice thing with it is the taxonomies is the same vocabularies. So you can share the same vocabularies among all the members. We have exactly the same code for the warning list, I will explain later on, but it's exactly the same model, so the taxonomies, it's collaborative, it's JSON file, simple one, where those are potential list of false positives. Everyone knows the case where someone put a loopback address in IOCs, or put whatever IP addresses from Google. The idea here is to prevent this, and provide a way of warning the information if something goes wrong. Then recently we did a new models called the Galaxy. So a lot of people were using MISP and they say we want this kind of intelligent, trade intelligence tools. We don't like the word intelligence, put it between brackets, it's something that we try to avoid as a word, but the Galaxy itself is to provide a layer, an overlay of categorizations over your event and so on. And this one is quite interesting because we already provide by default redactors, tools, and so on that are using. So in the next version, so 2.4.56, it will be enabled by default, and then you will be able to already tag and classify your redactor. And it will be in addition to the existing information. So if you look at the features, basically it's free and open source. Just a side note on this. If someone wants to enter, I can do that. So for us it's very important because the project is free and open source software. It's under the GPL licensing. So meaning that everyone can contribute, but the thing is we have multiple copyright owners and we want to keep the software as free for always, and that's very important for us. So basically, MISP won't be forked into private software and so on. It's an GPL licensing, so it's basically there for the community and remain for the community. That's very important for us. It's a clear goal when we set up MISP. So in MISP, we have many functionalities. We won't do an exhaustive search of all the functionalities, but we will highlight some. If at some point you want feedback on some, we can discuss about it. But one of the most important ones is automatic correlations. Each time that you put information within MISP, you create even an attribute, they will correlate automatically. So if you have similar attributes and so on, you will find automatically the correlation. It's one of the most interesting features. You have sharing groups too. The distributions model of MISP is quite flexible. You have a default one, and then you can even extend it to specific sharing groups if you want to make a Hadoop group for sharing for specific analysis and so on. And you have plenty of other things, but I think we'll go into detail about this. By default, you have many support formats that are included in MISP by default. So if you enter an indicator in MISP, you can use them for your tools, your system, and so on. For example, you might have Suricata IDS in your infrastructure, Bro IDS, no. So as long as you enter an IP addresses, for example, as an indicator, you can generate automatically from the API or from the user interface rule set for your IDS. Same for the SIEM, we have an export module for Ceph. If you know other modules that can be supported, you can add them. We have export for OpenIOC, Sticks, Sticks 1.1, JSON, and XML. We support CSV format. We can export Jara rules, so set of Jara rules, hashes of files, and so on. We have nice extension modules that can extend Maltego directly in MISP. So you can basically integrate MISP to get even from MISP and export back from Maltego to MISP. We have things from like DNS policies for the one using black holing or using name server, like the FPZ files. So basically all the evolutions arise, it's the various communities that are using it. So here you have an overview of what are the groups. So as Circle, we operate multiple instances. We have one big instances that we use for the private sector, and this one is counting more than 600 organizations, so it's quite huge. There are daily events that are created and exchanged, people contributing, adding comments, proposal, and so on. So it's a very active one, and this one for us is very interesting because it's providing a lot of feedbacks to improve the software and how it works. We know that many people are using MISP for various use cases. Some are unknown, hidden, secret club sharing things. You have other clubs that are more or less known, that are partially sharing and keeping in island mode some of their data. But that's really showing that you can have different models of sharing. You have even like people from Fidelis, I think John is there at BotConf too, is running a MISP dedicated to a specific use case of malware, and this one is free access, so people can just get access to it. So you have different models of community that you can run as you wish. Obviously, financial sector is becoming bigger and bigger. Recently, we had a lot of questions regarding it because there are some changes for some vendors that could basically stop starting this, and then they are wondering about open source software doing it. Another thing is we have a large user base on the military part and international organizations. So for example, NATO has a huge group using it. A lot of national governmental certs are using it. We operate one of the MISP instances for various national certs. So the interesting part for us is basically from this feedback, we basically gain many features or bug fixes and so on. So it's really coming from real use case. So one of the core functionality, and this one is, I think, the most important. If you get this concept, you basically get the MISP concept as is. We don't see the traditional model, which is some feed provider where you are basically producer and then you have consumer. We are not really that model because our use case is not that one. Our use case is basically people contributing. People using the data, contributing, and so on. And everyone can change, they can change their jacket at some point, saying, I'm contributing all the day, and then one day I'm just consuming the data, which is fine. And that's the idea behind MISP. So when you have multiple MISP connected, you can create an event initially, and this event contains some attributes. And then you can add more information at the end. Perfect. So you can add attributes, and then you can benefit back from the thing. So the idea behind MISP is basically everyone can contribute, and then if you contribute back, it will be propagated to the other nodes. Obviously following the classification and distribution mechanism, but it's basically the idea. And for us, the most important thing is easy to use at the end. So just to go into the technology part and so on, the attribute of MISP can be seen as sometimes observables. So you might have heard the term in sticks, for example, where they use the term observables. Sometimes you have seen the term indicators. But basically, in MISP is generic enough that you can define anything you want. So it could be vulnerabilities, it could be financial indicators, it could be various things. And then these attributes is usually linked to an event, which is a generic structures containing some meta information like dates, information, and so on that contain the information. This one is basically the attribute and event is basically the core mechanism in MISP of exchanging information. The format itself now is going to be an internet draft. It's an internet draft that we maintain, so it's the format itself is documented, so you can even support the format as you wish. It's pretty standard. And the thing that is quite important for us is the attributes. It's completely dynamic, and it's coming from the usage and people asking for attributes. For example, the financial indicators, we're bringing to it because we need it, especially for dry desk cases, where we wanted to have it. And that's another thing is that we want to compare over some standards. In some standards, the time of improving the standard might be, I don't know, 1, 2, or 3 years. So if you have to wait for 3 years before that you have a new attribute that you can add, it's kind of a pity. So you really want to be able to include new attributes as soon as possible. Another case was the Bitcoin addresses. I don't know, 2 years ago, no one really cared about Bitcoin addresses, but nowadays a lot of people are using it for correlation. So we basically integrated because we wanted that people can use it. As I said, this object in Galaxy, but that's the next versions. To go into detail for indicators, indicators are the generic definition. It's basically a pattern that I can use for detection of suspicious activities. In MISP, we are a bit more granular on that. We have the attribute itself that can be a specific type, so like network indicators, system indicators, bank account details. But attached to that, we have additional information. We have what we call an IDS flag, and this one is misnamed because it's not only for IDS, but it's for anything. It determines its information, so the attribute can be used automatically. So you can use it automatically. So if you have, for example, descriptions, usually you don't use a description automatically. But if you have an IP address that can be used, and you show this one for detections, you basically set the flag. If you have an IP address which is 888, because the malware is testing the internet connectivity using the recursive DNS of Google, you can still add it, but usually you don't set the flag because this information cannot be used for detections, because you might have too much false positive. So it's very interesting because you can basically see if an indicator itself can be automatized or not. Another thing that is quite interesting, we add a category. It's not something that is enforced, because if you use some API in MISP nowadays, it will define for you a category, a default one. But the category itself can describe an attribute. If you have an IP addresses, you want to know in which context we are. For example, you might get it for the payload delivery. So at the initial state was the attacker or the adversary was doing, or it might be later on when you do generic network detection. So this kind of category are quite useful because it's basically giving you some additional context. And then you have a command field attached to an attribute. So with all this information, you can find back the contextual information related to an indicator. Another thing that we wanted, and this one is for us as software developers and so on, is a huge thing to have to take care of. There is not a single interface when you want to contribute in this. Some people might want to use a web interface, some people want to use the API, some want to use templating, but we forget there. So, and then the free text import. Some people want to use their own tools, so they want to remain NIDA and they don't want to leave it and contribute back to MISP. So that was, for us, it was very important when we designed the software. Users can basically contribute in various interfaces, and it should be the same for us. And we should not force any user to use a single interface. I know it's painful, and that was one of the design decisions. When someone forced you to use a Java application to put indicators or to use a web interface that is utterly shiny but not practical enough, you won't use it. So that's the idea behind. People have different interface, but for us it's more work because we have to maintain all this interface. And within MISP you can contribute, so you can propose changes and so on. A quick example, and we have many use cases for this one. It's a very simple one. I'm pretty sure you are familiar with it. You receive an email from a colleague or a friend or another organization like, oh, we have seen this and how are the indicators? Now your first question is it in MISP? Do I have it already in my systems? So in MISP we have a very simple feature. You can basically put random text in a field and you will try to figure out if there's any indicators. So it works for PDF document too. So you can select all, paste it, and try. So it's very nice because automatically it will detect the network, the indicator type, but it will detect the correlation too. So if you already an event with all the indicators, and you will see relationship with existing event, don't need to add it. You know already the information, you know that it's processed and so on. So for us, it was like a simple, quick win, but it's very useful. Even for people that are very technical, sometimes they have information or crappy report in PDF. I will show you another module that we did for this, which is using a similar way, but before we do OCR. So sometimes you get images or facts or scanned documents that you have to import. We have a module for doing that automatically. So like that you just type the image, a scan, and automatically will propose.
Is this available through API as well?
Yeah, very good questions. It should be, I think. It's a good idea, but every time we are talking about it, but we should provide it through the API.
Right. It's actually a very small change we have to do, so we can do it very quickly. Okay.
Maybe we should open an issue. Yeah. So that we keep track of it.
Yes.
Is that under the added event that you
Yeah.
get the free text
It's
document?
populate from, and then you have free text.
Okay.
Yeah, it's maybe quite hidden, I think, the features. Because we had people using this for 6 months or 1 year, and they said, does it exist? And say, oh yes, yeah. So maybe your user interface is a bit clumsy, so it's difficult to find back the...
It's already a huge improvement because it used to be the tiny icon there of the attributes, if you can show it. It used to be that icon and nobody noticed it, so we now have an import from .NET list.
But this one is quite nice because you know that sometimes you have a way to encode URLs to avoid to click on it. When you do security and you exchange URLs, you don't want to click by accident on a link. So the tool is able to detect that. So automatically we extract and basically unparse those ones, and then they will be inside. Okay. Same for classifications. What we have seen is, and again it was from a mistake, in version 2.3 and early 2.4, what we have seen is people were starting to use tags, and it was like a disaster. Complete disaster. You had people that were just putting malware names and so on. And it was like, wow, it was a pity because basically we were like, what can we do for it? Then we were like looking at everything possible, and I will explain about the classification, but we find a way to have classification that is defined, or taxonomy that is defined as generic one, and you can basically use the one that you want. I will go into detail later on this. Another options, this one is quite nifty too. Imagine that you have a bank that want to share indicators and events, but they don't want to put their names. In MISP, you have what we call delegate publications. So you can create an event just for you, and then you can delegate it to a third party, and you just cherry pick from your community or whatever organization that can do it. The nice thing with it is basically the initial organization know about the event because obviously they share it, and the one doing the publication can accept or deny it, but then it will be published from the second organization, so the one that has the delegation of publications. This allows to share a nice event, but from a third organization. So it's kind of pseudonymity, For example, some events that are published under the name of Circle are coming from other organizations that want you to publish events. But they still benefit from sharing, because if they get feedback on this one, they can just have a look at the event. Then we have the sharing groups. And I think we will go maybe more in detail on this, but the nice thing with it is you can mix up. So for an event, so you create an event, you have attributes. You can mix the sharing, so you can have globally sharing, so you share to all the MISP that are connected. For example, share some indicators, like for example, bank account, to only the bank sectors. So like that, you can have in one shot all the events, but the sharing mechanisms are just different within the event. This one is pretty new too, and I think it will grow more and more because it's linked to the false positive things too, is the citing support. So the citing is basically to tell to someone that you have seen an indicator. So you have an IP address somewhere, and you have seen, oh, I have seen it too, and then you can click on it, and automatically it will tell the original MISP that you have seen it too. So nice thing you can see for per organizations, but you have an API. If, for example, you just put a citing on a specific IP, all the related events to the same citing will be updated. I will explain how to use in PyList.
Can it be removed? For example, I make a mistake, I click on it. Is there a way to say, oh, it's a mistake, I actually didn't see it?
Yeah, I click to open a second.
You shouldn't have a second issue. The thing is, initially we implemented the sightings for an organization called NCSC in the Netherlands, so which is the National Cybersecurity Organization in the Netherlands, because they wanted to have a specific use case for sightings, where people can change it and so on. But nowadays, that more and more people are using it. But, yeah, this one is a good point too. In the recent version, it even indeed changed the timestamp now, so you can automatically see the timestamp. You mentioned a bug that I didn't know about that it was missing the sightings at some point.
It was not persistent. I used to click on it and then change view, and then it was not saved.
Okay.
But this is okay.
That's interesting. I'd love to hear more about that.
And then we support various ways to update it, and you can import it through a JSON, and if you are brave enough, I would say, you can use the stick sightings document. It's for an IP, it's basically a 2-page XML document. But we support the simple JSON where it's just 2 lines. So like that we are compatible, so we can do both. But the idea behind is, more citing we have, we can refresh indicators. As maybe some people in the audience know, intrusion detection systems has a problem. You cannot put enormous number of rules within their systems, so you are limited by the number of rules that you can put. So if you have a MISP and you have, I don't know, millions of events and millions of attributes, you just want to publish the most refreshed one or the most recent one. So the citing would help to reduce the set of IDS rules to the one that you really want, and the one that has been seen by others, which is the most important part. Another thing that we have seen is basically the false positive, which is recurring challenge. So we will show how it works with a MISP warning, but it's basically a thing that could help to support the day-to-day job of the analyst. We have already predefined lists. Those ones are public, you can contribute more. So for example, the RFC 1918 network space are described, public DNS resolver are described. I know some use case where the ISP are using it, where they put in the warning list only their backbone infrastructure IP addresses. So like that, if there is any hits on that, they will automatically see in the event that they might have a hit regarding critical infrastructure. So you can use it in both ways, like warning saying that this might be a false positive, but you can use it as a warning saying that this one is very important and I need to look at it. Yeah, this one is quite important too. We'll go into detail later on, but very often you have people that are, so the initial use case of MISP was the following. People at the MISP, they are connected to the internet, they are connected to another MISP, and they exchange information between the two. Traditional way of doing it. But what we have seen is more people having multiple MISP internally. you mentioned a good point regarding, for example, sandboxing. So you might have, for example, a sandbox, could be, for example, cuckoo, sandboxing, where you need to automatically put the event into MISP. But you don't want to pollute your MISP with tons of analysis that might be an issue. So you can basically, from cuckoo, put it into MISP. You can have the same for any other systems, but you still want to be able to synchronize. So the nice thing here, it's basically with MISP, you can set a local flag, and that saying that all those MISP belong to the same organizations. So in this way, you can still synchronize local events, even that are basically local to your organizations, within your different MISP. So it's kind of cluster of MISP.
Yeah, just something to add to that, and you can set up all sorts of rules between these MISPs, so you can filter the data, you can cherry pick the data that you want to move over from one of your internal MISPs to another. So the idea isn't to synchronize everything, but to take the subset, for example, from your sandbox reports that are interesting enough to be shared with your community, and just manually pick those out or set up rules on tagging and then send those events over. But we'll get to
We can show cherry picking, so I guess it's more practical. So and then you can use it, for example, if you have a MISP for interacting with a third party, you can basically use it for keeping some local events and sharing the rest with the others. Yeah. 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 Another issue that we have seen when more and more people are using MISP, but the newcomers, that people are coming into MISP, they're like, okay, great, I have a MISP installed, and then how can I create an event? Or how should I create an event? So how does it look like? And it was a very good point, indeed, because for us it was like obvious, we have a software where people can share indicators and so on, but it was tough to find a way to basically already provide information. So within MISP right now you can provide, you have default feed, so you just enable it, and you get OS in feed. The next one we provide from Circle. There are others, feed, but the nice thing with it is basically when people look at it, they start to share indicators, they imitate, so they mimic what you do. So by doing so, you provide kind of good practices for our users to create their own event. You can have a look later on, but it's very interesting. The thing is, it's completely open. I will explain in PyMISP how you can do it to generate your own feed, but you can use it for example, imagine that you have a MISP that is basically on a unconnected networks. You can do that. You can have, but you still need to sometimes to pull data from one place to the others. And you don't want to have a full MISP synchronization, you are afraid of the security risk over it and so on. So you can basically generate JSON files that are the ones from MISP, and you can put them on a staging server, on a whatever gateway that you want, a USB key, and then the generation can be done automatically. And it's basically 3 lines in Python to configure it, and then you can have your indicators. Recently we added the CSV too, so that means if you have any feed on the internet having a CSV text file, you can just add it and it's automatically into your MISP dataset. We should provide in the next versions default feed, but if you, for example, use abuse.ch feed, you just add it and automatically it will be into MISP. Okay, just to conclude on this quick introduction information sharing is basically what we have seen is information sharing practices is coming from usage. There is not that much really models or practices that are, it's usually from day-to-day usage. And more you share, more you have correlations, more you see the stability of some attackers, more you see that some IP that reappear every time. So it's really that from the regular usage of the information sharing that you can spot various things. As I said, MISP is just a tool. We don't have anything to sell. I mean, MISP is a free software, open source. Why we do so is just that we want people to do information sharing. Because for security is the only way that you can go. The attackers are doing it, but we don't do it, or we don't do it that much. So we really need to more do information sharing. And that's the idea behind. And the idea behind too is basically MISP itself is a free software, people can customize it and meet their own needs. I don't know if today for the community here, but I know some people are using MISP for customizing tracking of adversaries. I don't know, one case where they use MISP for just looking at exploit kit, So he's gathering all information about the exploit kit, and he's just looking at all the exploit kits using MISP. You have other people that are using it for specific kind of malware. Some people are using it for sharing information about GPS coordinates, whatever. They can do it. It's just a matter of how you use it. So that's just this part. I don't know if there's any question for this first part.
Can you go back briefly on the feeds?
Yeah.
How to add other feeds?
Oh, but we can actually
We'll show it.
Are you sure?
Yeah, we have it in the part, in the upcoming part.
Well, I can actually ignore it. Just break the line. Okay. No, I see Robert doing something.
Yeah, yeah. Looking for the pretext.
Yeah, great. You can go to it. Yes. Okay. So here, you basically have the two default fields that you might know. This one are more that you have it. Okay, this one are only for if you can just reduce the size. Okay. So how does it work here? You basically have a name, a feed provider, the provider itself, an URL, which is the default one. You can you can basically go directly in the configuration, so it's maybe easier to. Okay, so you can just say that the feed is enabled. You have the provider, uses the type of source format that you can have. You can have the simple CSV parse feed. So you can basically use a MISP feed. You have a free text parse feed. So if you don't have it via the API, you can still use it through the free text there. That's one way to do it. If you click on that. Then you can target an event. So it can, each time that it's pulling is creating a new event, or you can fix a specific one. Then you say which field that you want from the CSV. In this case, it's easy, the list of IP addresses. We can override the IDS flag. We can basically do delta merge, so updates only. It's very interesting when you have fields that are regularly updated. You usually want to do delta merge. Auto to publish, you can each time publish, but if you do that, don't forget email notification and so on. And then you can set the distributions. You can set a default tag. We will look into the tags later on, but you can, this one, for example, is coming from OS in source field. It's a block filter list, but you can set your own specific tag. And then you have filter rules. I think for this one there is none, but where you can specify the tag and so on, but which is not valid on this one. You just type the tag that you want to exclude or include and so on the organization. So if you go to the list feed, it's challenging, yeah? It's using the trackpad, so for the first time. So if you go to the magnifying glasses here, you can even pre-browse the feed remotely. So this one is, so you can, even if you want, you can even cherry pick automatically the one. You see automatically the correlations, but this one makes sense, it's basically the same file, so you see the correlation, but you can have, so you can even use it as a kind of pre-browser, so you can even put a CSV file from someone else, you don't pull it, but you can already see the correlation. Is it already known, or is it? I have a use case that is very interesting. There is a guy that we know of working in large corporations, and he's buying feed from external vendors. And he's using MISP. For the first things that he's doing with it is basically to validate the feed from the provider. He's putting all the OS in feed that he gets, and he asks the vendor to provide a feed. He adds it into MISP, and if he sees how many correlation he has, he says, oh, you use this feed and this feed and this feed, maybe it's not so interesting to pay, I don't know, 20,000 a year for this feed. So it's a clever use of MISP. I was not thinking of it, but I think
it's a good idea.
Yeah, it's a good idea for evaluating feed provider. I think we should do a blog post evaluating feed provider using this. I think they will love us for that.
Why did you choose to put the same event for all those attributes?
Why? It's because each time you do an update. If you do an update every hour, that means you will have.
But that's up to you. You can set it up in a way where it creates a new one. You set up like weekly pools. That's up to you how you set it up. So.
But it's really depending on the use case. Someone want to have an event each time, but our use case for this machine is mainly, for this instance, is maybe a regular update. So.
Yeah, the only thing to keep in mind is if you pull into a new event each time, it will always correlate with the other ones. So after a while, you're going to have a massive list of correlations, and it becomes a bit unuseful.
Yeah. So it's a very handy way. So the idea, if you go back to this feed, it's in the future version of MISP. By default, we had the default feed, so like that people don't have to look on the internet to find a feed to add. But and then you can fetch and force to fetch all the events and pull the event. This one can be scheduled too, and that's basically it for the feed.
So it's either schedule or manually approved.
Yeah, exactly. The scheduler might change soon too. Yes. Because
The schedule right now is a weak spot that we're replacing because it's a nightmare to use. So, and what we want to do with it is for you to be able to set up parameters, because right now the only things we have in the scheduler is just pull all events at this time, and that's not very granular, so it wants to use parameters for it. So pull this instance every X hours, that instance don't pull at all, and so on. So, yeah.
Where is the feed listing on the site? Like from the homepage? Where'd you go to?
seeing actions,
Yeah.
is feed.
Okay.
But if you are just a user, you won't.
Won't have that. Okay.
Yeah.
It's random. So.
Yeah.
So sure.
Yeah.
Okay, I'm going to decide, I think.
Yeah.
Feel free to talk at all.
But maybe there's, you can just focus on the real case or for the use case.
Yeah, actually. Good. Okay, so can
I can give you, I can put the slides.
I... Okay. But you don't want to show demo?
You want the slides or?
I have both.
Yeah, you go.
Yeah. I was hoping that.
No, it's fine.
Yeah, so by the way, if you have the VM, then here are some credentials for you if you want to have a look at it, but it's also up on the website, so I won't do that for you. If you need it anytime, just let me know and I'll go back to this slide. So what we're going to do here, and we're going to skip over some of the parts to go a bit faster, is first let's talk a little bit about the data model of MISP, because Alexandre has mentioned a lot about what kind of data we have in there and how we organize it roughly, but let's have a more detailed look. Who here hasn't used MISP before? Do we have anyone? Okay, so perfect, so this might be useful. So first of all, everything that we store in MISP is built around an object called an event. So that's our central generic metadata container for data. So basically an event for us can be a lot of different types of things. It can either be an actual event that happened, so that could have an incident, it could have been an attempted incident, and so on. So it could be a lot of things in that regard. It could also be simply an IP watch list, it could be the result of an analysis. So it's basically a data package containing all of this sort of information that we've already talked about. So an event for us is a container that has some metadata fields. Here are some of those listed. It is a creator, so you basically, the event tells you who has created this package originally. This travels with the event from instance to instance, so even if it was created several communities away, you will know who was the original creator of it. There's a description that is supposed to tell the user what this package is, and it's also giving some feedback on the analysis level and threat level that the event has reached, so the maturity and threat level. And it also contains information about who this information can be shared with. And this is something that MISP will automatically use by itself, but it's also required for the users to actually adhere to that. So if we go on, each event is described by attributes. So attributes are, as Alexander already mentioned, the meat of an event. So those are the indicators, the pieces of information such as external analysis, links, attachments, malware samples, and so on. Each of those are described by a category and a type, with the category telling you what this attribute is describing and the type telling you how it is describing it. So as an example, payload delivery would be a category, so it is describing that story, and it's describing it by, for example, an IP source address. Then I already mentioned the IDS field, and the only other thing that's interesting here is the distribution, really, which means that we can also define the distribution levels on attribute level and have more restrictive settings on certain attributes than the general event packages. So you can, for example, keep certain internal attributes that you say, this is for my organization only, for example. This is the internal reference that we give to this event in our own ticketing system. So this is something you don't want to share, but you can still store in there. So each of these attributes correlate with other attributes in the system, which means that if there is a match for certain types of attributes in a different event, then this will automatically create a correlation between the two. This means that if you're looking at one of the events and you have access to the other event on the far side, then you will see that those two are related immediately.
Just for a question,
Mm-hmm.
what are the attributes that are matching more frequently, IP addresses? Or?
Yeah, for example, right now it's very simple string matches. So basically, the types that we have for matching are all kinds of indicators like IP addresses, domain names, host names, file names, hashes, and so on. So it's a long list of what can match.
The most common correlations are, depending on what you share as attributes,
Yeah.
but the most common one are hashes, network IP addresses, that's the most common one.
So then the other thing is, and this is what Alexander already mentioned, is the collaboration factor in this. So what we wanted to do is, we wanted users to be able to still own their own data. So we don't want anyone else to really change the data by themselves, but they should be able to make suggestions on how to change it. So for that we have the proposal system, which basically allows any user that has access to an event to say, I don't agree with this attribute the way it is, or I have additional information to this event, and add that in the form of proposals. So proposals then will be propagated back to the original creator, even if it was several instances away. It would jump back the same way the event came from. And it would allow the original creator to accept that change or decline that change. And when it is accepted, it is turned into an attribute and propagated back all the way out. So basically, what we've tried to do with this is to still allow you to make changes without, but with the consent of the creator of the event. And as you can see here from the fields, it is very similar to an attribute with some small changes. It carries the organization that has proposed the change. This is something that we keep track of to show, first of all, for to sourcing the others promoting the work, so that people that propose a change, they feel they get something out of it by also having their list on the contributors on the event. Okay, and then Alexander already mentioned tagging. So basically, tags are also something that can connect events, so to say. So correlations are something that happen automatically if there is a matching attribute found, but sometimes you will see some similarities between events and you want to mark that as a similarity. This could be something as simple as saying all of these come from OSINT sources, to something like saying these are all events that are based on some actions of a threat actor, of a common threat actor, and then you would bind them together with a tag. And the good thing with that is that you can use these tags in your exports, in your APIs, and you can also use it by the UI and group events based on these tags.
Will it propagate to the creator as well?
That is up to you when you create the tag. So tags are either exportable or non-exportable, so you can keep internal tags. where you say, for example, if you would want to have internal references or references to something else within your internal system as a tag, you can absolutely do that and it will not be exported, but it can still be filtered on, which is still handy, or you can just say, I want this tag to be propagated out.
You can even restrict the tag to an organization.
Yeah, true. So that's another interesting case that we have, that we have some tools that we use for automation that filters on tags. So we have some tags that only we can set, so you can restrict it to one organization, the handing out of a tag. And then if we tag an event with this tag, it will be picked up by that external tool that is querying the API periodically for events with that tag.
So we use IntelliMQ for processing the takedown notice that we send to the ISPs. And what we do, when we have an event where we want to send takedown, we just have a tag that we have, but only us can add it to not interfere with our process of takedown. And then when the takedown process is done, the tag is removed automatically. So it's very handy to do automatization in that way, so you can have custom tagging locally.
Yeah, and now that you mentioned custom tagging, one of the things that we had after a while was the taxonomies, which Alexandre briefly already mentioned, which is basically something that takes all of these tags and normalizes them. So the idea is that we have a standard library of naming that we want to be reused across instances, so you don't have several different tags popping up for the same thing, especially for automation and exports and filtering. This is important that when you type TLP Amber, for example, in your search, that someone didn't name it something else and it wouldn't show up in your search, or wouldn't show up or be blocked by your filters. So with the taxonomies, we're trying to have a huge list of tags that are maintained and kept the same between instances. And there is some automatic normalization going on. For example, when you enable the taxonomy for TLP, for example, if someone has used different capitalization, it will automatically normalize it for you.
Also, your takedown notice, did you use taxonomy instead of just normal text?
Yeah, it's for the takedown is an IntelliMQ classification that we have, which is in IntelliMQ. But for the takedowns, for example, that is processed is a custom one. We didn't publish that one, but will be. We have one for the ticketing system. So for RTIR that we use for the ticketing system, we basically have the statute that we update into MISP. But we didn't publish the other one, the automatic. We could.
But the idea with this is especially if it's something for you to keep inside the organization, so it's just as easy to. I mean, if it's not something that you're going to share, you can just name it whatever. Okay, and just one more thing here is we also have a discussion system on in this, but it's tied to the event. So it means that there is a small forum-like discussion below each event where you can discuss with other people that also have access to the event. So the idea with that is that all of those discussions have the same restrictions as the event itself. So, and this is what is coming up in the near future, the changes. The galaxies, as you can see, are sitting on top of an event. So basically each of the events will be tied to a galaxy cluster, but we'll talk a little bit more about that later on. And then the other change that we're going to be working on soon is the objects, which are basically an element that is sitting between an event and an attribute, and it binds several attributes together. So right now, our attribute list is pretty flat. So you have an event that is described by a set of attributes. But sometimes what you want to say is that it's that this event, which could be describing a malware, is described by separate malware samples, and each of those samples have a set of hashes. They have a file size, they have a file name. So more than just single atomic elements that are thrown into an event. So what we want to do is we want to build these templates for these attributes that allow you to create more complex data within the event. And this is an ongoing project. So but Alexandre will talk more about it and how to contribute to that if you have ideas on what kind of templates would be interesting in this in the future. Okay. So let's look at what MISP actually looks like. So what I'm running here is basically the MISP that is on, on the VM. The data that you can find in there comes from the open source feeds that are in MISP by default. So these are the MISP type of open source feeds. And as you can see, when you log into MISP, this is what you see. This is each one of these lines is a separate event that has its metadata, such as info, distribution, so the things that I've already mentioned before. And here are tags that are applied to each of the events. So in this case, you can see that it's using separate taxonomies to describe different parts of the information. So for example, we're using the circle taxonomy here to describe the topic of the event, so finance, and we're just using the TLP taxonomy to describe the TLP. Okay. So generally, whenever you use MISP, you have two context menus. That's something to keep in mind. The top menu tells you which environment you're in. So right now we are in the event actions environment. If you want to go into the administration environment, then it has its own submenus. And on the left, you always see the menus that are related to that context. Okay. If you want to, oops. Yeah. If you want to filter the data that you have in MISP, you have various ways of doing it via the UI. So the simplest is using the quick filter. So here I can say, for example, finance, and it will automatically parse all of the fields that are relevant for this. So that means tags, description field, attribute values, attribute comments, and so on. It will narrow it down on the list that contains that keyword. If you want something more complex, we have this filter tool where you have a bunch of parameters that you can use to refine. So for example, you can say that I only want events that have distribution connected communities and all communities and nothing besides those two. Then as you can see, it will add those two parameters to the list. You can also negate in this and set up a very complex filtering rule, and you get a URL with it that you can then reuse later. So a typical use case for this is if you have a senior analyst that is reviewing the events of the junior analysts before it's being published. So we have a separate publisher role. So you have the junior analyst that can create the event, and then it goes through a review process. So what you could do, for example, is a senior analyst could set up a rule to find all events that belong to his or her own organization and that are not published yet. And then every morning just check whether, or every afternoon, whether there are any events in this list. And then you can just say, bookmark the URL and just always check quickly whether there is anything like that. So it's both useful for retrieving the data that you're after and also for automating some of the work processes that you have. Okay, let's move on. So if we look at an individual event, again we get the metadata on top. So this is pretty much the same what we've seen on the event index, with the difference that you can already start altering the tags if you have permission to do so. And then below it we have the list of attributes. So let's go with, there we go. Okay, this is good. This is interesting. But anyway, so you have the list of attributes below it, and each of these attributes is described by a value. That's the main contents of the attribute, of course, and then you have the category and the type next to it, comments, and whether it should be sent to the automation export, so the IDF flag. What you can do here is you can immediately edit and propose changes to it, depending on what access you have. Here we're logged in as a site admin, so you can see both the proposal changes and the actual changes. Normally you won't see that if you're a user. Okay. Right. So let's look at what it would look like if we created a proposal. So let's say that we see this IP address here, and we think it's a false positive, so we want to tell you and the original creator that this is a false positive. It shouldn't be sent to the automation, so they can still keep it in. What we can do is we can just propose an edit, uncheck the IDF signature and click propose. And as you see, we will have the original attributes still here, intact, and we'll have the proposal under it with the changes. One thing you can do, and this is an issue that we've had several times, if there is a false positive coming from an external source in an event, and the external source is not very responsive to proposals, so they're sitting on it and not really looking at it, you now have a setting in MISP that allows proposals to locally override attributes. So that means that, in this case, this attribute would already be blocked from your exports. So this is something that you can enable or disable on your instance, that's up to you. It won't take into account any changes to the attribute apart from the IDS flag. So that's the only thing that you can automate to be overridden. So this is simply just to block false positives from not being removed from your system. Okay. And in this case, if we're also a creator, again we're logged in as site admin, so we can do everything to be able to show this. This is what it looks like to accept or discard a proposal. An alternative is if you absolutely don't agree with an attribute, you can also propose to delete it. So that would look like this then. So that's up to you what makes most sense for in any situation. Okay, and then right below the event we have the discussion that we talked about, so you can send messages, and it will also be sent out in an encrypted email to the creator of the event. It is only visible to those that have access to the event itself, so it's just as restricted as the event. Other than the filtering that we've seen before, there are some other ways to find the data that you're looking for. So we also have an attribute search that is, that allows you to search in various ways. So one of the typical things is that you get an event from someone, or you get information about the event and you get the UID. You can check that quickly here whether you already have it, or if you get the value, you can check that if you already have an IP address. You can just paste it in there and it will show you whether it's in your system. One of the things you can do is if you were looking for if you're looking for some values and it's contained in your MISP, you can directly download it in various formats. Okay, this one is pretty clean, but it allows you to immediately download it in various formats as search results. So you can say that any attribute that I found using those search parameters that I've entered, I want to extract as JSON or as a CSV and so on, and you can absolutely do it from here. So going back to our event, another thing that you can do, and that I haven't mentioned before, is looking at the correlation. So let's find the event with correlations. So here is a very heavily correlating event. Maybe that's a bit overkill, but here's a simpler one. So this event, as you can see here on the right upper corner, it correlates to 13 other events. So that means that if you hover over any of these, it will give you some information about the metadata of that other event that it correlates to. And if you scroll down to the attributes, you can also just see correlating attributes. Then you can see only attributes themselves that are actually correlating the other events. If you're more the visual type, you can just click View Correlation Graph, and it will draw a graph of the current event and how it correlates to everything around it and what attributes it correlates to. You can play around with this and you can keep expanding the events. I'm running it in a weak laptop with a VM, so I won't play around too much with it because it will probably kill my performance, but yeah.
And every attribute is correlated.
Yeah. So yeah, so you can get into situations like that. So it's obvious that these two events are highly related, probably based on the same report or analysis of the same sample and so on. So yeah, it's a simple tool, but it's also a very powerful one on seeing the relations between events. Another thing that you can do that's kind of similar to this is if you start pivoting through the events, you see that it's starting to build a little chart of the path that you've taken, so you can use this to move back to a different one. And if you're, for example, working on a report on how some of these are interacting with each other, this can be helpful of creating that chart for you. Okay, let's move on. Yeah, so let's just have a look at how to create an event, and we're going to be a bit brief on this because this is a horrible time sink. So in order to create an event, you first get a form that where you fill out the metadata of the event. So this is very simple. Who do you want to share it with? What's the current analysis level, and so on. For the distributions, we'll go more into that later on what the options are. Right now we don't have sharing groups set up here, so we need to add one, but we'll get back to that. So once we're fine with what we have in there, we create our event, and it's going to create a framework for the data, so we don't have any actual data in there yet. In order to populate that, we have basically 4 or 5 different ways to do it. So the most basic one is add them by hand. That means opening up a form that you fill out, and you just set everything up manually. And that means you need to know already what category and what type you want to use. This is fiddly, and it requires that you are intimately knowing how the MISP categories and types already work and what's there. So very often that's not the case, so there are much simpler ways to do it as well. So one of them is the free text import, where we can just say, and then you can, paste something in there, write something in there, whatever, and let MISP figure out what's going on. So in this case, what it found is it found an IP address and the domain name in what I wrote there. So when you get to this screen, you can make some last-minute changes. So MISP isn't sure about whether this IP address, for example, is an IP destination, an IP source, or maybe both. So you can make some refinements. It tries to pick the most common use case as the baseline, and then it lets you make changes. Same with the category. So an IP address could be one of these 3 based on the mappings that we have. And when you're satisfied with it, you can add comments. You can also do match changes. So if you, for example, import a list with 1,000 IP addresses, you don't have to go through one by one. You can just mass change all of them. So that's absolutely up to you. And then you click submit, and then it creates those attributes. And another thing, and this is something that we'll just touch very quickly, if you want something even simpler than that, but something more structured, there's also the templating, where you can create a template for your users to just fill out with data. And this makes it as simple as you can imagine. So it's a form that tells you, under here, if it's a phishing email template, please enter the email address where you've got the email from, what was the subject, and so on. So you can set it up any way you want. So as an administrator, you can create these templates. We have a few samples in there so you can see what it looks like. And then the users just have to fill this out. I'm not sure how often this is used, because most of the time when people deal with MISP, they already are past this stage, but it might be useful in some organizations.
When you use the free text import, is the full free text saved somewhere, or is it only transferred?
No, but that's a very good point, so we should probably save it as an attachment. Yeah, indeed, we don't, but it's a very good point.
Could be the same problem with EOCF.
Yeah, we talked about this already for modules, but not for the free text input. So yeah.
Thank you.
It's a good point, thanks.
How would doing an event or listing of IP network scanning activity differ from, say, the sightings report that you mentioned?
Sorry?
The sightings report?
So sightings are different. So basically, the IPs that are in MISP are from users that say that I'm creating a report, this is the information that I have. And sightings is basically just saying, I've seen that too on a specific indicator. So that means that if there is already a report about something in MISP, the user can go in there and just say, I've seen that, and check it.
Okay.
So that's it. It's not enabled on the demo instance. We can enable it, yeah. I'll just enable it quickly.
So I would go on the specific attribute and then click the thumbs up or what have you.
Yeah, it's like a Facebook like.
Yeah, okay.
I'll just enable it quickly.
That you check the parameter.
Yeah, so basically we have a very complex admin tool in there that allows you to change all of the settings in MISP via an interface. It does a lot of checking and it gives you suggestions on what you have probably misconfigured or not set up yet on your MISP. For example, if we push a new feature with a new version, we generally don't enable it if it alters the behavior of MISP, because we don't want people to suddenly be surprised about misbehaving differently than they did the day before. So we have all the new features disabled by default, so as an administrator it's a good idea to just come in here and have a look at what's new. And it also has a bunch of diagnostic tools, so if you're running into any issues with MISP, it probably won't work for me because of the internet connection, but yeah, it's probably timing out. So it's also checking whether your version is up to date, so it takes a while until it gives up. There is no connectivity. But anyway, now the site should be enabled, so let's go back here. So as you can see now we have our little like buttons. We can just say, okay, something went wrong here. Okay, there we go, that was great. So in this case we've added the citing to this event, which means that we're logged in as a MISP organization right now, so it says that MISP has reported this one once already.
So if I'm, for example, if I'm searching attributes,
Yeah.
and then I find those hits,
Yeah.
I could, is it more beneficial to create an event or just simply do the watch or both? Because if I create an event, it will correlate the activity.
Yeah, indeed. So it depends. I mean, this is something very quick.
Yeah.
It's really depends on the use case, but
Yeah.
if you have an intrusion detection system and you basically use the data set, the existing one, for an IDS and you see some hits, I would use the sightings. On the other hand, if you have a new report containing the similar values and so on, I will create a new event.
Yeah.
There is another thing that the sightings also track the counts. So if you have your IDS automatically hooked up to send feedback, then you would also see you had 500 different hits on this. And another interesting thing with that is that you, for example, see that the time intervals when it was done, so it shows the timestamp as well. I think the version might that will be exactly as well. Yeah.
Okay.
So when you need to update MISP, it's very straightforward because basically when you do a git pull, I don't know if we really had the demo effect or not.
I think I have tried to do it as well. Give me a second, I'll just restart. Yeah, virtual box point tricks on me.
So basically with MISP, if you need to do an update, when you git pull new versions, automatically the first admin that will log in will do the update of the data model and so on. So it's transparent. Meaning that if you have to maintain a MISP and you just git pull regularly, you just need to log in as admin one time and then automatically will be set up. You might get a warning for the first one, but that's it. So usually it's straightforward to do an update. If you have internet access, obviously. I mean, you see that basically you did the update, and you can even show the log.
Yeah, that's true. So in the logs, what you would see, for example, in this case, we have successfully executed the SQL add sightings and so on. So it automatically runs all of these upgrade scripts in the background. Before we had a very difficult to follow upgrade procedure. Right now, just git pull and log in once it's a site upgrade. That's it. So yeah. And if we go back to that. So now it shows you the timestamp. So if several organizations keep adding sightings, then you will see a list of which organization has seen the different dates and so on. And you can also keep adding for your own organization, and then it will show you the count on how often it was seen. And then you get a summary of the on the event of all of the combined number of hits. Okay, I think I know what we showed there. Yeah. So as you can see here, we had 2 combined hits on this event, all by the same organization. If you're running a MISP, you can also set up whether they should be anonymized. So sometimes You want the total number of how often something was seen, but not disclose who it was seen by. So that is up to you and how you set it up. It's also in the server settings. Okay. There we go. Oh yeah, just one more thing. Another way to populate an event with information is to use one of the import modules or one of the import systems that you have. So, for example, if you go to populate from, you see the free text import was one, but if you have an open IOC file, you can also just upload that there, and then it will try to parse it and find attributes based on that. We also have an import system that Alexander will show later on. With some examples. So you can build very simple Python modules for the import. The idea was originally we had it all in MISP, and modifying that, first of all, it's PHP and nobody wants to touch that. And second of all, it was complex and you have to know the internals of the system. So right now, it's very simple. All you have to do is you have to tell this small Python module, if you get this data, what you want to convert it to, and that's it, and this will handle the rest for you. So the moment we released the system, I think 2 days after, we got a massive module from Passive Total that was surprisingly comprehensive for 2 days. So
we have now a new one. It's coming from Domain Tools. It's work in progress, but it should be merged quite soon. So sometimes the problem that we have is basically we need to have access to some data set or vendors to update the modules. Domain Tool, we find a deal where basically they provide us access. We can use the access and so on, but at the same time they just ask us to, in return, to create a module for it. So if at some point a vendor that can give us access to the API and so on, we are willing to create the modules as long as they can give us access for testing. Just a quite a win-win.
Yeah. But sometimes with Passive Total,
with Passive Total it was directly the. And I think the guys over there are very good, so they know what they do, and they do a very clean and neat module in Python. Yeah.
It's also, if you're thinking of building your own module, they have a blog post about how it works with a video, so it's very nice. Worth having it. Okay. Okay, distributions. So this is something that we've mentioned very briefly, but let's have a look at what it actually means. So in this we have 5 distribution settings. There's a 6th one, we'll talk about it in a bit. So basically, you want to do the drawing? Yeah, sure. All right, I can do it if you want.
Yeah, I'll do it in sentence.
Oops. It will be a bit uglier if I do it. But okay, so basically, if we start from the fact that you have your own MISP, and you are an organization on your MISP, and you want to create an event that's only visible to you. So that's what we have the organization only setting for. That means nobody else in your MISP will be able to see. It's just for you. Then you have this community only, and by community we kind of mean everyone that has access to that MISP, but I'll go a bit more detail into that. So basically everyone that can connect to this MISP and has a user on this MISP, any organization, will have access to it. What this means is, if you have a partner that runs their own MISP, but that has a user on this MISP instance, if you set this community only, everyone else will be able to see it, but this user is a part of your community. So that means that they can take the event home to their instance, where it will automatically be degraded to your organization, only to their organization, since only their organization are part of your community. Connected communities is kind of the same idea with a third hop. So that means that if you create an event with connected communities on this instance, it will be propagated over here and will become community only. Since it means that connected community means my community and all directly connected communities. And then if any user from this instance pulls it back home to their own list, it will become your organization only. So this was the old method that we use for sharing information. We have old communities where it just says, just keep going as far as your list is connected. But now we have something more granular that is useful in some cases, but it can also become a burden at another time. So our recommendation is generally to use these for most of the cases, unless you, for example, want to do some ad hoc sharing, or if you want to create a specific group for a subset of the organizations. An example for this is a financial sector one, for example. So if you have a MISP like we do, where we have different sectors sitting on our MISP, you might run into a situation where the financial sector wants to share information just between themselves and between nobody else. And for that we have the sharing groups that will probably have the chart for that. Yeah, here we go. So this is an example of a sharing group setup. So we have 3 MISP instances. Each one of them has 3 organizations on it, going from 1 to 9 in total. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And sharing groups are basically distribution lists that can include organizations and instances and the mix and match of the two. And something to keep in mind is when you create a sharing group and you name an instance, you can say that it should still adhere to the organization rules, or anyone on this instance can see it. So that is when you create the sharing group. So in this case, what we have is we have a sharing group with 3 instances included. So instance 1, 2, and everyone on 3. So we have the all flag set for the 3rd one. And then we have organization 1, 2, 4, and 6 included. So that means on our own instance, for example, are shared, 1 and 2 are included, but 3 is not. Then we have on MISP 2, we have 4 and 6 included, but 5 is not included. And now this one, everyone's included because of the all flag. So you can absolutely do that. And another thing you can do is you can extend the right to edit or to add to the sharing group to a 3rd party. So for example, if you want to exchange information with a different sector, so for example, you want to exchange information with the medical security sector, but you don't know anyone in there except for one organization that you trust. You can say, I trust you with this. Here's the description of the sharing group that says releasable to these and these types of organizations.
If you want, it's a coffee break. So we can do a coffee break in 2 minutes. Okay, no problem. Okay, great.
Okay, so you can absolutely do that. So you just create a sharing group and extend the rights to this organization, and then they can add other ones to the list. This is of course a matter of whether you want to trust this to someone else or not, and it's completely flexible.
Quite often the case with law enforcement, where we know a point of contact in law enforcement in other countries, but we don't know what is behind. So if I have a point of contact in France at gendarmerie, I have my point of contact, but I don't know what is behind because it's huge. So I delegate the extension of the group for France to someone at gendarmerie, and then they can do whatever they want and add the other users. But you still need to trust the users. But it's a nice way to basically extend groups by delegating the role of extending groups.
Yep. And I think there is and yeah, we can also show this, but maybe now. Yeah. Okay, I'll keep this. Yeah. So
another use case for sharing group that we have quite often is we basically work on a case which is quite sensitive. I'll just take an example where we discover a malware targeting some European institutions, but we know that it's maybe coming from, just an example, UK. So you don't want to have a all share group, so you basically put all the national servers for the country, but you basically exclude the UK server. Or it could be the same if it's a malware from France and you just exclude the others. Just an example. But sharing groups can be used for other groups for incident response.
Okay. So if we look at this is a blank list right now, we don't have any sharing groups created here, but let's have a look at what it looks like to create one. So it's split into 4 different parts of the creation. First of all, you have the general part where you fill out the metadata about the sharing groups, that means giving it a name. The idea with the name is it should be easily enough to identify for your partners. So this is what will appear on the event and so on. They can of course browse it, but it's important to have something concise. So here is an example. And then you can have a releasable to tag, which is not used by MISP directly. This is meant for other users. So the idea with this is if you have someone that is allowed to extend your sharing group, they should be able to understand from this one line who it is releasable to. So in this case, it should be sector organization. It's a bit redundant. That's fine. And then you can have a description. This is completely free text where you can go into more detail. We're not going to do that for now. One thing that is interesting here is you have a little checkbox at the bottom. And this is, and you can make the sharing group selectable, or what we also call in other places a MISP active. So what that means is when a user is tagging or setting an event with a sharing with a distribution level, they can choose this. The idea behind this is if you create an ad hoc sharing group, you don't want to pollute the list of sharing groups in the future with it. Once you're done using it, just unselect the check mark and it will disappear from your list. But all your events that are there with that sharing group will still appear to the same rules. Once you're done with that, you can start adding organizations. There are two types of organizations that we differentiate between. Local organizations and remote organizations are basically the same internally in MISP. The only difference is that you expect local organizations to have users on your instance. So this is just a flag that you can change an event, but you cannot start adding users until it's a local organization. You will often get a lot of remote organizations. Whenever a partner synchronizes events to you from third parties, you will get them as a remote organization. If they ask for request to your MISP, you can just flip them to a local organization and start adding users for them. So here you just select which source of those two pools you want to start adding organizations from. So in this case, we don't have many options on the test VM, but we're going to add Circle to the list. So as you can see here, you are always included in the list, so your organization is always included. And additionally, we've now added Circle, and we can choose to give them extend rights or not. So that's again the decision that we talked about, whether we trust them to extend it further or not. So in this case, we're going to trust them. And we add another third party organization, remote organization, in this case, Cthulhu SPLR. So now we have a list of our organizations, and then we can move on to the next stage, which is the instances. So by default, our own instance is included. We can either say our instance is included with that organization filter, or we can say everyone on that instance should be included. Another thing that is quite handy is that if you use the all orgs flag, the organizations are not named. So if you have a community that you want to share to, but where organizations are anonymous, that way it won't show up in the list of the distribution partners. And you can start adding other instances. Right now we don't have any connections added to this list, so we can't add anyone, so we're going to skip that. There's also this roaming mode, which basically says ignore the instance restrictions and just check which sync user is allowed to fetch or pull this data from this instance, and just move it in that way, in all those directions, and keep going as far as the organization distribution list allows it. Generally, I don't think this is used much, but there's an option. And once you're done, just to avoid issues, because this is, of course, a critical part of distributing your data, you don't want to accidentally over-restrict, or if you don't want to, for example, just say, I want to share this with everyone, whilst you actually only have a subset of your community. What it tries to do here is it tries to formulate an image clearly what is going to happen with the data that you mark with the sharing group. So it takes all those settings and it tells you that from the local organizations it will be visible to these and these organizations, and these will be able to extend it. From external organizations, it will only be visible to this organization. Nobody will be able to extend it from the external organizations. And then the same thing with instances. So in this case, it says that the data will not be pushed because we didn't add any external instances. However, it can still be pulled with the same rules that we talked about. So if someone has access to it here, they can still pull it over to their instance. Once you're done, you click submit, and you have your sharing group created. And if you go to an event, you can start using the sharing group setting now, because now we have a sharing group, and we can start assigning that sharing group to the event or to attributes. So, should we take a coffee break?
Okay, thank you.
Sure. Okay. So, just a quick more thing about the exports of the APIs. So, basically, all the data that you have in MISP, so what you've seen until now was how to use it with the UI, but of course, if you want to use this information in other tools, in devices and so on. So there are separate ways to do it in MISP. The most simple one is if you just want to grab an event and export it, we have a small download as button, and then you can choose one of the formats that you want to export it in. So we support quite a few formats out of the box. But as you can see down here, the last option down here, the self export, that's actually a module that's loaded externally. So again, if you write a simple Python module, it will show up in this list, and you can use it to export the data. So this is simply for exporting a single event. If you want to do something more comprehensive, you can use the cached exports, which generates an export of the entire data set that you have access to within that MISP. So you can say generate a cache for something that's okay. So for example, if you want to generate suricata rules, you can click generate here, and it will tell the background workers to start working on generating an export file based on that. Okay, in this case it was quite fast because you don't have a lot of data in this list. And then you can download it, and it's a full set of data. If you want to be more granular and select subsets of the data, you can use our APIs. So we have a bunch of different APIs directly in MISP, and also an external library called MISP that allows you to build Python tools that interact with MISP immediately. So that's basically it for the usage part. That's what we're missing still.
Okay, so one of the use cases that we had too is, so you have seen the user interface, it's nice, shiny and so on, but basically sometimes you just want to do your work from one place without touching the rest of the infrastructure, so you basically want to remain in your infrastructure. So I don't know if someone here use Viper already, if you've never heard about it. So just summarizing, Viper is a binary analysis tool and management framework. So basically, it's a kind of command line tools where you can store all your malware, all you do your analysis, and do it from one place. And the nice thing with it is basically you creating kind of cases where you can add more and more malware all together, and you can basically classify them, organize them, and make your work easy. And then based on that, you have many modules. For example, you can analyze PDF, it's doing a function for you, and so on. So it's very easy. And you can even create plugins to extend Viper itself. So the nice thing is the command line interface is really solid. You can do many things. By default, you have tons of modules. You have PD export, you have Varus Total, you have Microsoft, whatever Office that you can support. You have Elf Analysis, APK, and stuff like that. Then you have many third-party services that you can call, like MISP. That's one of the modules that we maintain, and it's quite exhaustive, and I will show you quickly how we use it at Circle. Varus Total, Cuckoo, Link, and you have plenty of interaction with IDEN and Radarly. So for example, when you do work with your malware, you want to load it into your disassembler, so you can run IDA remotely directly from it. So it's basically a kind of zoo where you have all your information, you can do whatever. There is a web interface, but we don't really use it. If you go on Viper and you look at all the commands installed, you can see that you have plenty of things that you can do. You can, for example, check the APK files. You can have a lot of extraction from P and portable executable information. You can analyze flash objects. So when you do rebrowsing, you get a PDF or you get a malicious file, and then you want to hold from one place. I think Viper is a very nice tool for that. So the thing that you can do, for example, is
the idea behind Viper and MISP, we wanted to have kind of remote storage within MISP. So that means you have the sample within MISP, but you still want to use it from Viper. And that's the idea behind. So the idea was to basically able to search, for example, from Varus Total, to download the samples, download it and put it back into MISP. You can, directly from Viper, you can create an event, you can even update it, you can upload the samples, and so on. So you have plenty of things like, in MISP you have many Yara rules, so you want to run the Yara rules within your Viper, to find for a specific binary stream and stuff like that. So basically that's the idea of interactions, and you can do everything you do from MISP from a Viper interface. The thing that we do at work is, in our MISP, when someone creates an event, automatically we do the cross-check update with Varus Total from Viper. So it's triggering Viper and automatically expanding. So if, for example, you have a malware from a report that is basically just a SHA-1, you will automatically find out on Varus Total if the SHA-1 exists, and then you will auto-expand to MD5, SHA-256, and so on, automatically into MISP. So the idea is to do auto-expansions using Viper as a backend. So if you use Viper, you basically have a command within Viper called MISP, where you can call whatever thing you want. You can set parameters in the configuration file. You can pass the parameters like URL and key. The key is the API key, the URL where the MISP is running on, so the instance. So you can do stuff like upload the malware sample to MISP, you can download, you can search, you can check for the hashes, so you can cross-check the hash. I will show you how it goes. It's very straightforward to do. You can initialize the sessions, you can basically add attributes to an existing event. So if someone already did some work or it's coming from automatic analysis, you get more things, you can add additional things behind. You can switch. So for example, you can search for hashes and IP from the current MISP event and download the samples. I will show you directly an example from. So we might fail, but will work. Okay, so this one is a session that I'm running on an operational machine in our place. Okay. So here on the left side you have Viper sessions with MISP events. This one is a 4660 and with VT expansion. So the idea behind is you see the check hashes functions. Viper will do for you everything back to Varus Total. So we will automatically expand the thing. So you just specify your event and automatically we will check on VT all the samples available in VT and just update the attribute accordingly. So it's a very nice way to use Viper. You can download the sample and so on. But what you can see is basically when you create sessions within Viper, they are linked to the event. So you can find back which attribute and which malware you are currently using. So it's just a use case. So this one is just a sample use case. Same for the VT module, so you can basically directly use VT from Viper, and then if you use VT within Viper, you can upload it into MISP and so on. That's, I think, quite handy. Something else. If you do reversing, sometimes you are traveling, you don't have MISP access and so on, you do locally other things. What you can do with Viper is download all the samples from a specific event or a set of events and work locally on the current event. For people that need to travel a lot, or for example, to do remote site incident response and don't have direct access to MISP, they can still continue to work on it. And that was the objective, is basically you don't leave your CLI and you continue to work at that place directly. We maintain some of the modules because we provide those services too. Basically, you can have access to our modules to passive SSL and passive DNS. So automatically, from Viper, you can access Circle passive SSL, so you can see the cross-check of an SSL certificate.
So for example, if you have a certificate that has a pillar of a specific IP addresses, you can cross-check on which other IP this certificate has been seen. So it's very handy. So like that you can find, for example, similar infrastructure that has been used by an attacker reusing the same certificate. Same for the passive DNS. You can query passive DNS things directly from Viper, and then you can populate back the information that you get from passive DNS into this. For us, we can directly launch, when you download sample from MISP into Viper, you can then launch your radar installations, your IDA, whatever ensemble you use, to start the reversing of a malware. Passive SSL is straightforward, same as MISP. You can basically query an IP, SHA-1, and you can download even the certificate directly from the interface. If you're interested into this, we give access to a security researcher, SOC and so on, so you can get access to it.
Is that instance hosted by you guys?
Yeah.
Ah.
So passive SSL and passive DNS is something that we operate for years now. But this one is using a standard format, is basically the one from Circle. Same for the passive DNS. You can query an IP in a domain and you get back the stored passive data. That's basically it for Viper. I will go into detail with PyMISP later on, but basically the framework itself is just a module relying on PyMISP, which is the API accessing on MISP, and then basically that's a MISP. Yep. Then modules. Don't see the modules. And just text them.
I suppose that everything can be scripted in a way. For example, there's a repository that will contain samples, and then automatically they will be picked up and sent to Viper. Viper will send to MISP and do all the query and enrich the database.
Yeah. Right now, with Viper, you still need to do the action yourself, but you can pass the parameter to the CLI. There is no real API to Viper itself to automate Viper. You can probably do it easily through the Python modules. But as far as I know, there is no way to automatically script a full session in Viper. Might be useful at some point. So, yeah. But I need to open the issue on Viper. Not for me, but I think I will open it. Another thing that we recently added is a Python modules in MISP, so the module for doing the extension. So this one is a quick introduction how to do the extension yourself and create your own modules. Okay, so before API, you were forced to use the API itself, so the PyMISP and so on. But it works really well, but the only thing is not tied to the user interface. So you could not benefit for your module from the user interface in MISP. The problem too, and Andreas mentioned it too, is basically you don't want to touch the PHP core. Even if it's well written, it's still PHP, and you know everyone has PHP, so you don't want to touch it. Classical problem. So that's why we started to work on modules. So the goal that we had initially is basically to have a module functionality where you don't touch the core. We want something that is so simple that no one doesn't need to just learn the internal of MISP, just to look at how a module is done, and that should be done. And the module should be as lightweight as possible. So it's not something that you need to compile and so on. It should be as easy as possible. And friendlier language, so it's not PHP, at least it's Python. Just a side note, we are Python 3, and it's Python 3. And only Python 2. So just to be clear, if someone wants to make a branch for Python 2, they can do it, but we don't support Python 2. So all as it works is we wanted to have a simple REST API to find automatically new modules added, and we can add anything. So for example, looking at Viper, you can add any libraries within Viper into it because it's just Python, and you can create your own modules. So the module were installed with import-export in 2.4.50. So this one import-export was quite recent, but we have more and more modules. I will show you some examples of modules. Yes, to update the slides, but okay. The idea with the modules is, in some organizations, you don't want to run your MISP instance where you get internet access and so on. So you want to separate your MISP instance from auto expansions and access and so on. So the idea behind is the module itself can be run on the same systems, but they can be run somewhere else if you want. In a DMZ somewhere, running on a dedicated system, you can do it. As I said, Python 3, if you need to install it, it's basically just a repository with the modules. It's completely separated. So if you want to even use the modules without MISP, you can do it. So you can use it for anything else. The installation is very straightforward, just one my eye missing, but that should work already. So that's basically it. So how does it work? There is a very simple, so it's by default running on 46666. You have a simple URL query where you basically, on this URL you can query to get all the modules available. So you just run, it's just giving you a list of the modules available. And then based on that, you can query, depending on the module installed, how to find it. The nice thing with it is automatically when you run the modules, if you enable modules in MISP will connect, do the introspection on its own, find the new modules, and they will be automatically available. You just need to enable them or disable them. Or set parameters, because for example for VT, passive total, you need keys, so you need to set up the keys. And then automatically, if the modules require a configuration, it will be in the settings of the modules. So maybe we can show later on. So if you do a curl on this URL, you will get a JSON file. The JSON file is very straightforward. You basically have a description of what the module can do. If the module can describe what it's doing, usually you are fine. So module type is expansions, meaning it will be expansion services available in MISP. This one is DNS. It works in two ways. You can be an expansions where you add proposals, or it will be hover, so that means you go with your mouse over it, and it's going the expansion automatically. You have some meta information, what is the modules, and then the most important thing is what is the input. It's basically hostname domains, and the output is IP source IP destinations. That's it. So that's how a module is described. So if you go to the next one, so what you can do is basically you have to query it. You know that the module is called DNS because you get it from the introspections, and you query the hostname. Automatically with the result, automatically the values, with the type IP source or either IP destination for this IP addresses. That's basically it. That's all the communication works between modules, MISP, and MISP modules. So how it's integrated in the user interface. So if, for example, I take an enrichment module, just take the DNS one, it will automatically propose you the services. And that's this user interface interaction is basically what you have seen in JSON just before. Nothing black magic, it's very easy to do. In the UI, same stuff, enrichment, so that's the one that will use the expansions. While the module is running, localhost 4666, you enable the DNS module enable true, and that's it. You basically get this expansion automatically. And that's the way it works. More you add additional services, you just get a new modules activated.
And could this be automated again? So you don't have to select every time that you run DNS, every time there's a domain, automatically, if the domain is known, then it will add it.
So, that's we have. So basically, we're working on something similar to that for a while now, but something that we need to finish in French, which is exposing all of the imports, exports, enrichment to the API. Because the moment we do that, then we can absolutely just automate it. And for example, run a job that checks based on tags, for example, which events it should just parse and automatically enrich it, and so on. So indeed, I think that would be the best option. Or to have something directly in this, where you say automatically if the type is added, then just run it.
The problem for some expansions, in plastic DNS, you might have a lot of entries, but you still need the work of an analyst to validate those data. So that's why a lot of enrichment modules are validations.
But it could be done as proposal.
Yeah, sure.
Indeed, you can.
There is one more issue why with some of them you want to be more selective with what you send to it. Is, for example, you might not want to share that attribute with the external source. So for some modules it might make sense. As long as we configure with warning lights and red lights and everything, it's probably...
Yeah, it's a good point. That's something that we will add, but how to implement it is not so easy. But now, from the API point, I think we could have something easy to use from the API. So just for the module type, you have expansion modules, import, export modules. Expansion modules have two subtypes, other types. So it's showing the expansion values directly on the attribute. Expansion tab showing the expansion value via the proposal form, so basically a proposal. And then import, export modules. I can show you live on an instance, two different modules. So we'll just create an event for the test. I will add an attribute, and I will choose to add a vulnerability. So, then a vulnerability. I'll take a vulnerability, so you know all the CV ID by heart, I suppose. So everyone knows this one? Yes. RTF exploitations. So automatically this attribute is added, but as it's a CVE, there's a CVE module of our expansions, so this one is automatically going to our CVE services, doing the lookup and doing services. When I was doing the other, it's basically the MISP module behind the scene, doing all the JSON, interaction and so on. And you can add anything you want, depending on the module that is activated. It's one way of being modules. That's a expansion modules over. I will show you a more funny one. And this one is not enabled on this instance, but on another one. Yeah.
Also, the description could have been added as well as one of the attributes.
Yeah, sure. But it's not the case here, but it's something that could be done here. For the expansion on over, it's just visual. But this one is not as a proposal, but it could be as a command. To extend the modules of CVE to the common and common. Yeah.
And then we have to say command. Sure.
I think I need to change the module for that.
Yeah.
Okay, this one is a test instance, so I basically have a test event. And then on this one I have some module activated, including, for example, OCR. So on this one it's very straightforward. I can upload the files. So this one is a PNG, just a test. And then you have some value there. So it's a PNG image. This one is basically importing to the modules. And the module is loading automatically the OCR, putting in free text. And then you can basically find the indicators that are added.
What's the use case?
The use case is, for example, trade report where images are in. It's a very common thing. So even, for example, FireEye is used to that. They do PDF document and then they add stack of images. Other use cases are faxes. Some organizations are still using faxes for exchanging information. And other strange use case, we still have the same for fake invoice, for example, it's scan, so we need to automatically scan the bank account and so on. You have some mistake because it's an OCR, obviously, but that's why it's a proposal that you can change.
And it's in the beta file form.
Sorry?
It's already inside the beta.
It's already in there. But the OCR module, you just need to install Tesseract OCR on the machine. But the module is standard, full Python. So I think we will show you. Here it's an example how you can create your own modules, expansion modules. So basically for modules, you need this kind of information. The error you will output, the attribute supported, the module information.
Then you have a handler. The handler is basically when you query the modules with information for the JSON that you pass. You have an introspection, but the introspection is what you have seen, the MISP attribute, input, output with the data, and then the version that's returning the versions. That's basically it. Then if we go into details, for the modules of the DNS, we have here input, hostname, and domains. That's the type that we will expect as input. Output IP source or destinations. And the error is just the error as we wish. Then you can add some information. Then you say the module type, this one is just over. So it's just the information over. So it won't get as proposal if it's not set as expansions. Then you create the handler. So the handler is basically just loading a JSON. You do your code, and then you return the result with a specific value. So for the DNS, the most difficult part is handling the DNS queries. So you have a DNS resolver, the name server that you query. You try to do it, or you might have a non-existent domain, timeout, or some resolving error. If it's a correct result, you output the answer. If not, you will return the respective list. A bit smaller. So basically, this one is the resolver part, and then you have the full modules. Yeah.
I was wondering about caching, like, should it be implemented in the module or there is something, because if I start overlaying again, I will start querying again.
Very good question. So there's two parts of it. There is a caching supported into MISP. So basically, so when you do the over, when I did the over of the CV, it's already cached. So
okay.
It will not do the JSON query
Every time.
Because if you have a lot of users, it may be.
On this side, it's if you hover over the same thing twice. So whenever you load the page and you hover over something, people do one node. And from then on, if you hover over it, no, but there is the other one.
Yeah, and there's an helper in the modules that is doing the caching. So like that, you don't do the full query. So if you do the helper with the caching is done in Redis. So you basically, but the module needs to support it. So it's just one line to say you cache and return values.
Okay.
Because you have two problems. You have the problem of the user interface when you do the query and the caching. And you have the second problem of caching if you have a pay account. For example, a passive total, you don't want to do 10 queries for the same IP that you already get the information. And then you will waste a bit of money. So that's the two caching that we implement. I don't know if it answers your question.
Yeah, thanks.
Yeah, the DNS module doesn't have it, because we don't pay for DNS queries until now. I'm just kidding. But then if you want to test it, you need to copy the modules into this one has been changed because the module expansion name is different, but it's fine. Then you restart the server modules and you will see all the modules started. Then you can test your modules if you can get the introspection back with the module supported. So if you want to test, you can test it directly with a true MISP or via curl, and you can do query in JSON. All the test files are done in JSON, so you can even see the example. Same for another one. If you need to pass parameters, exactly the same, but you have to basically set a module config. When you set module config, username and password, MISP will see it, and it will propose you in the configuration to set the username and the corresponding password. Because PySSL, so the passive SSL, need username and password for notifications. We have some expansion modules probably. I think we are missing some there, but more are in the queue. So it's really straightforward to implement. So import module is exactly the same idea behind. The only difference is basically when you input the data, you need to either do a file upload or a text paste. So the two options are valid. So from the user interface of MISP, you can either upload the files or put the text paste directly. And the output is basically the parse attribute to be edited and verified by the user, but it could be free text too. So you can input back the input into free text, like we do for the OCR. So you can chain at least those two modules easily. But it's okay, so connector to Sandbox. So we have only some modules that are currently available and available in parameter that can be used. If you want to create an import module, it's exactly the same idea behind. Then you can have a user field with, you can specify some regex and so on to strictly validate what the input is. Here the input source can be a file or a text, so you can either upload the file.
So just one thing with the user config, one thing that you can do, for example, is if you have a service where you expect the user to provide an API key, then you can, for example, have an API key field that you have in the import module directly, and then the user will have to paste it and it will be passed through the module to the service. So yeah, the idea behind that is either that or to refine the services, something we don't do in the original modules.
Yeah.
But,
Indeed. And it's basically the same. The thing is, when you download the file, upload the file, it's basically passed in base64, so you get the file uploaded as base64. The PNG I uploaded with yesterday, it was in base64. Yeah, the same for the introspection, so you can have the configuration and so on. Export module is exactly the same model, but the model is basically you get an event. So we are working on collections of events, so instead of having the module set per event, it can be a selection of the events. Still not implemented, but it's... for example, the export modules, there is one for Ceph, which is the common event format, where you can export, so it's basically reading the JSON files and exporting it to another format. So it's very handy because you can create your own modules and handle your own format as an external feature. Same for export modules, so if you want to create an export module, it's basically the same model. The only thing that is different from the other modules, you have to set the main type, or which type of format that will be supported. Exactly the same kind of structures where you have a handler, introspection, and versions. Again. That's the famous response time that you should put.
there is just to write that in the French, but there is one thing that you can also do with the export modules. You can oh, that's right. Alright, forget it.
Okay. So that's basically exactly the same. The magic that you return the file, you export modules, and that's basically it.
There we go.
Yeah, exposed to the API, that's the thing that we want to do. Yeah, we are planning to move it into a different way for when you have some process that take a long time to be processed. Just here it's still fine, but you have other module that might take much more time, sandboxing and so on. So it's to be completely synchronous. So we have already a messaging system that we use for some export in the ZMQ, but we want to expand it for the module systems. So like that you can pass jobs to be processed, and when they are ready, they will be appear for the user interface, but like this is completely asynchronous from the user interface. Yes, the import is, that's basically the modules interface. So if you want at some point to come with new modules or idea, just open an issue and we are more than welcome. As I said, if you have format that we don't support and you want us to support it, if you have an example, we can have a look at it and see if we can support.
Okay, now maybe there are questions too much.
Okay.
So I can do this as well.
Okay, sure.
Sorry. Okay, so we already talked a little bit about the taxonomies. The idea with this was that we had all of these tags that people were using that were not unified in any way, and wanted to keep it simple. So you already know the background of it. So let's look at it. So yeah. The idea was that we wanted a very simple system to build these classifications and also to use them in MISP. With this early tagging that we had, there was not only no standardization of the specific tags, but also the format on what these tags should look like. So people were just pasting their strings into a tag and just using those. So the idea was, in the end, that we settled on, was to use machine tags for it. So just to show an example, the idea was to use a triple tag format where we first had a namespace for the entire taxonomy. So in this case, here in the example, you can see Admiralty scale, which is used for classifying source reliability and information. What is it? Also reliability.
Quality.
Quality, yeah. And it's used, for example, by NATO. So that's, we're just going to use it as an example. So as you can see here, we have first a namespace, then we have a predicate within the taxonomy, and then the actual value for it. And then we also have a more human-readable version that we use for displaying it to users and to describe what the tag actually is. So we ended up with this. It's still very simple. It's still a simple string, but it already tells you which taxonomy it is from, what within the taxonomy it describes, and what the end result or what the value of that is. So the idea was to have something that's simple for anyone to implement. So we have the modules there where you still need to know Python, but very often what we found is that classification is done by people that are not really as tech savvy maybe, or not used to having to implement anything like that. So we have something as simple as JSON now, and there is also something in the works to make it even simpler and have a form or something to even simplify it further. So because as we found, even JSON can cause issues for someone that is not used to having to write these types of documents compared to just filling out forms. So we're going to go a step further in the future for that. But already now creating a JSON is very simple. So we've gotten some very surprising contributions from some surprising sources. And the idea is that we want people to give a way to describe their events and categorize their events based on their own naming. And this is something that we've seen with some other standards, that they try to force you into their own naming conventions for categorizing, but that won't mostly work because all of these organizations have their own internal systems, their own internal naming systems. So it's kind of shoving a square peg into a round hole. So we figured this will be an easier match for most. And until now it's been working out great. We're now working on also a way to have an ad hoc mapping between these various vocabularies, because even though we limit the use to a few vocabularies using taxonomy, so for example, we don't have that much overlap, but we have some between some of these taxonomies. We want to be able to yeah. And by the way, all of this is up on GitHub, what we have right now. If you have ideas for new stuff, just open an issue, or even better, create a pull request. We always welcome new ideas. And if you just want to keep it internal, that's fine too.
For example, if you have givers as what we call vernacular name, so just the common name, you automatically have the automatic expansions. So like that, you don't need to know what are all the other names used by taxonomies and so on. You can just use one for specific.
So one thing that we're talking about is to have a system where a user assigns any one of these, whatever is used on their system, and automatically silently adds all the other ones that are in the same group, so that when it is shared and someone is using it as a filter, it automatically gets picked up. Right. So yeah, so as you've seen, it's in a Git repository. What MISP does is, whenever you pull a newest version of MISP, it will also pull the submodules, and it uses the submodules, so it will fetch the latest versions of the taxonomies. And then within MISP, you can just click update, and it will just use the JSON file to update its local taxonomies. And yeah, once you have those in your system, you can also select which one of those you will use, but I think we'll have some stuff on that later. Okay, so here are some examples of some of the taxonomies that we have currently in MISP. I think some of it is cut off at the bottom. It's just some examples, so just if you go back one. So one of the things is, if you look at this list, you can see that taxonomies are used for various things. So it is used for classifying data, so that means, for example, the circle taxonomy, a lot of the tags in there deal with what this information package is. Admiralty scale that deals with how reliable the source and the information itself is. Or you have something like TLP, which tells you what you can do with that data. Or PAP is the same, but it's not in here. But yeah, so you have very different use cases for taxonomies, and usually you end up with applying taxonomies or tags from different taxonomies to the same event to really explain what's done with that event, what that event means, and so on.
But what's happening if I create a taxonomy for my own organization, but then I share the events?
Right. So the taxonomy itself would not be shared, but the tag would be shared. So each time, so we have a taxonomy which describes all the tags that are within the taxonomy. But when you apply one of those to an event, it gets created as a custom tag. And when you push it over to a different instance, that tag is carried over. So the UTR users won't know the taxonomy, but they will know the information that you put on there. So they can still see the expanded value and see what it means. But they won't get the full list of taxonomies. They have to get it out of bound either through their repository or by just dropping the file in their MISP. So, yeah.
And then if you publish later on the taxonomy, you can still benefit from it. So it's not a big deal. If you create an internal one, and then you start to publish it on some event, you see that publish it is fine. But later on, if it's the same, it will be just integrated.
Yeah, because it's a very simple string in the end, the tag. So the moment someone later on gets the taxonomy through the repository, it will automatically be matched to that. Yeah, so it's... And this is what it actually looks like internally in JSON. So as you can see, we have a namespace. We have a description for the taxonomy. We have a version, so each time that gets incremented, whenever you get updated with MISP, it will fetch the data in there, otherwise it ignores it. And then you have the predicates, which are then, yeah. So these are predicates and the expanded values of them. One of the things that keep in mind that you can, even though it's a triple tag format, you can also just use namespace and the predicate without the value. So for example, TLP is one of these cases where you just have TLP red instead of anything else. Okay. And then you have the values themselves. So for a predicate, you have the possible list of possible values and their expanded values on what those actually mean. And also, it's as simple as this to build your own taxonomy, just publish it or not, or use it internally, and that's it. So what it looks like in the end, you can see the tags up here are some custom tags that were in the system, and below it we have Admiralty scale that get added seamlessly into your list of tags. One of the things that's nice is when you want to add a tag to an event. Maybe that's something that
actually maybe
what can you?
Yeah.
Okay, perfect.
You can.
Okay. Okay. So you can see here all our taxonomies on this MISP instance. So some of them are enabled, some of them are not, and even for the ones that are enabled, you can just select a subset of them. So, for example, with TLP, we have 6 tags out of 5, which means that we have a custom tag that matches the TLP namespace. So it's down here. It's a Chatham House rule. But for example, with TLP, if you have a system where you know that nobody will add anything TLP red to it, you don't have to enable that tag. You can enable just the rest subset. Or a good example is Varys, where, for example, forest fires are something that you probably don't want to use from the full Varys taxonomy. Okay. And if you just go to the event and try to add one tag. So.
Yeah.
Oh yeah, this one.
No, this one.
So if you go to add tag, you can see that you can either use your favorite tags, or you can have custom tags, which are the tags that are not in the taxonomy, or you can just go to all tags, and you can also filter if you start typing the name of something. So yeah. So and then it will select anything that matches ransom from all the taxonomy. So something that we want to do in the future here is just have an add all button. So for that way you cover all of the taxonomies, and at the end just hide the synonyms basically. Okay. And then, of course, you can use all of these immediately for all of your APIs, all of your exports, searches, and so on. So this number here shows how many events have that tag already applied to them. And if you click on any of the tags, it will automatically take you to the event index already filtered for that tag. Okay, and here's an example of using the tags for the distribution. So for example, you can restrict what data you exchange with other instances based on tags. So you can, for example, say, in this case what we have is, we want to allow anything TLBY to be shared with this instance, but we want to block anything that is circle topic finance. And we only allow things from the organization circle to be shared. So this is something very, what would you call it? So mostly OSINT data that can be shared with anyone, so low risk of sharing data. Okay, and you can also use these tags for other automation tools. What we already talked about is for picking up data that you want to interact with based on the APIs. So, yeah, indeed. If you can find it. Yeah. Where can this filter? I got a filter here. Okay. Let's see. Another issue.
MISP has got quite a bit.
Yeah. Yeah, it's used quite a bit.
So that's a famous exportable one?
Yeah, if you want to create a tag, this is what it looks like, and you have the exportable flag, which means that you can either include it in all of your export synchronization or just keep it local. You can choose a color for it, and then you can restrict it to an organization. So you can say that this tag can only be handed out by that organization. Okay. Yeah, and we already talked about those use cases indeed. So yeah, this is a bit unrelated, yeah. Okay, this is also interesting. So there is now a tool available, a Python tool, that allows you to interact, it's a library that you can use to interact with the taxonomies in a more simple manner. I mean, loading a JSON isn't that bad, but this makes it even easier to just interact with it. In the future, this is what will have the interface that allows you to create taxonomies.
Tools and taxonomies from Python. So it's basically a full-blown library in Python. When you instantiate the taxonomies, you automatically fetch into taxonomies from the repository, and you will represent it as a Python object. So you can basically apply anything from Python object. So you can list all the taxonomies, you can use descriptions and so on. So it's very handy if you develop a new application, so you need to rely on the taxonomies from it.
Yeah, maybe one thing to mention here is a license.
Yeah, so all the taxonomies are public domain, except if the author decided something else, but you can reuse it freely in any other tools. Our idea is there that the taxonomy should be as liberal as possible, so it can be reused in any tools, and using the same classification and so on.
So right now, one of the things that we're also hoping for and what we're pushing for is we're hoping that this will be included in Sticks 2 as well. As either marking or that way you could, because right now this is information that we cannot really exchange through Sticks with others, and it's something that we really want to start also exchanging, because a lot of the valuable information ends up in tags. So especially soon, once we start using galaxies that also use tags, a lot of the information that we share will be in the tags and not in the attributes.
You get a lot of contextual information that you are missing. Okay. Then there's an extension.
Yep. Okay. Yeah, the warning list. Right. So the taxonomies had this simple idea of extendability. But we figured, why can't we carry this on to other issues that we have? So one of these issues were that we got a lot of false positives in this. We have some ways of handling with this that we didn't talk about today. Yeah. So one of them is we have a regex system in MISP that allows you to set up what should be blocked on import immediately. So for example, if you can just show the regex filters. We use this for modifying data, for example, to something more common so that we have more correlations. If you look at Windows and the paths, in this case, a lot of the different Windows versions will have different paths for the same thing, so instead we use aliases for it in order to get correlations out of them. So this is one thing that you can use it for, or you can use it for blocking as well. So if for the regex tables you wouldn't give a replacement, it will then block. So if for example, one of the things that was why we had this initially was for sandboxes. We knew that we have the same false positives every time from the sandbox, and we didn't want those entered into MISP. So we just added those values as regex entries with blocking, and those are blocked. So this is one of the ways for MISP to block data that you don't want in there and false positives. Another is to allow the data to go into MISP, but to block it from exports. And this is the signature whitelist that we have. It works very similarly to this. We don't have any default values there, so it will look a little bit better.
For the regex, actually, you're really replacing into the attribute
Yeah.
the value.
Yes. So one of the things that we do here, and that's another interesting one, is, for example, for file paths that include a username, we sanitize the usernames, because that's one of the things that can accidentally go into MISP, and you don't necessarily want to share that. But yeah, and
This could be easily extended by using some logic, and for example, if you recognize that path, then you know that it's a Windows 7 or Windows 10 or whatever, and then it could automatically add an attribute by saying it was Windows.
oh, that's a nice idea.
Good idea. So then we can use the CP value.
Indeed.
Because the thing that you plan to expand soon is to have a way to express CP within a MISP event. But that would be a nice use case.
But I'm not sure if we should use the regex for it, or if we should have it as a different mechanism. Because that's a very interesting idea. Create an issue?
Yes. It's,
So you are showing us also how to open an issue.
By the way, we might not respond to some issues, but we keep in mind that when we get around to it, we have a lot of issues, as you can see.
some are basically support issues, some are requests and so on. So we deal with them, but it's basically just to track down, and then we have, when we see 2 or 3 users basically coming back on the same issue, we prioritize on those ones.
And some people are terrible with closing issues after they actually fix the issues, so blame those people.
Yeah.
But it's even if you're unsure about whether it makes sense, it's worth opening an issue and having a discussion about it. So very often what we have is we have several parties chipping in with ideas, and then we move from there. So it's a good first point of getting a discussion going over a new idea. Of course, the issue with Windows paths is the localized versions, which are a nightmare.
But that could be a logic, but it's a theoretical.
Yeah.
Creating the attribute depending
Or
on you enable those or you don't want.
Yeah. Or it could be a module where it was an example import.
Import. And that's what we do.
But in a way, like it's kind of like a hooking system to have some custom like code running when you add an attribute or when you import some stuff. So
Yeah.
do you have this kind of facilities in
For adding, we don't have a
it's kind of a generic hooking?
Yeah. We don't, but we should. We already have one for publishing. So when you publish data, you can run external hooks
custom
in Python.
Okay.
But we should have it for adding attributes as well. So that's something we should definitely do.
Yeah, that's a good point.
Yeah.
I will add it.
Is that it?
Yeah.
We'll remember to edit that.
Okay. No, we don't.
No, okay. Yeah, so basically the idea here was that sometimes you don't want to block the import of this data or the export, but you just want to tell the user that it's probably something that's wrong. So we came up with this idea that we should have a warning list. So the idea with this was it should also be as flexible to create as the taxonomies, but it should give a visible feedback to the user that's entering the data that what you're doing might be wrong.
I can do an example.
Yeah.
Maybe.
Okay, so as you can see here, it immediately warns that there's a potential false positive, and on the attribute itself it tells you as well which list it popped up in. So if you click that, you can see the actual warning list that we have in there already. And yeah, we have already quite a list of these warning lists. They're not enabled by default, so if you're running your own MISP, you can pick and choose what you want to enable. Some of them are a little bit heavier to use. For example, this one here will check against 6.5k values almost. The values can either be strings that it's checked against, or another thing to have is side annotation for IP addresses, for ranges. So you can have, for example, one of the things you can do is, if you are taking care of some networks, you can enter those side addresses for those, and if those show up, then it's something worth looking at. So, yeah.
Another case is in reversing. Very often you basically have hashes of anti-values, which is a very common one. You see on various data, you can just type the hash and you see the result. So like that you automatically get, oh, one of them seems to be an empty flag. Hashes value, so you want to review it. So it's exactly the same on the taxonomy. You can contribute your own. That's basically it.
But again, even with those, with an empty hash, it might be something that you want to convey, it might be something that actually happened and that you want to have in there. So it's not going to block you or anything, it will just be a warning. Okay, and what's the internet? Yep. So that's basically it. That's it.
I don't want to do my job. It's lame.
I didn't know what it is.
I want to get my mouse back. Oh, I have to. Okay, I want my mouse. Okay, so one of the most common ways to use the API in MISP is use MISP. MISP has evolved from something quite small to basically the most common way of using the API in MISP. It's in full Python, it's working in Python 2 and Python 3. As usual, Python 3 here is preferred, but Python 2 still works. So you have a big warning, but it's still fine. So if you want to install it, it's a pip modules, you install MISP and you basically then if you have access to a MISP, you get to connect to one, or you can connect to private sector one. Then you go to a specific interface, even automations. Andra showed it, it was basically where you have all the list of the API. On top of the page, you basically have your authentication keys. You just need that for connecting. And then the nice thing with MISP, by default, you have tons of examples. Then you can play with those ones to do whatever you want with it. So first, obviously, MISP need to be installed. It's obvious, but we sometimes have support ticket asking why it doesn't work. Then the second one, you need to create a file called keys.py with separate notification and dedicated Python files for the reason that a lot of people are leaking their keys where they should not. So how it works is basically specify the URLs, the key, and obviously you must always verify the certificate, except in rare case, but you have the same for the proxy support. So in case you have a proxy behind, you can set proxy values. It's basically the request headers, the request library with the addition. So basically that's the basic step to set up for having MISP running. Then on the example, you have tons of scripts. So they all follow the same philosophy. Basically, you have a -h for all scripts, so you can get an N. And then you have plenty of examples. One of those is search all. Is basically you can search for the whole database, look for any data, so it's like a full text search. You can implement whatever thing. You'll see that the code for it is very simple. Another one that is very often used is last.py. You have a CN. You need to look up regularly every hour, every day your data. What you do is use last, get the last data,
mangle it as you wish. You can make a script, a cron value, whatever, and then you can specify the time frame depending on how you want it. So when an event gets updated, time frame gets updated too. You have simple things like get.py where you can get a specific event and you get the full event. Then you have Yara.py where you can get the Yara rule set, Suricata rules too. So if you want to integrate to your IDS automatically, push the rules, you can just get automatically Suricata rules. They are from MISP. So basically, those ones are coming from Yara attributes. So if you set the Yara attributes, you get the Yara rules.
In the future, one thing that we might look at is generating Yara rules based on the attributes that we have. Right now, it's a specific type of attribute. So if you create an event, you can add your attributes, and in addition, you can add Yara rules for detection. And this one will collect those Yara rules, but you need...
For the pattern matching, for example, if you have artifacts that are with pattern in memory and so on, we could generate automatically the Yara rules. At the current stage, we basically take the one from Yara. It's not unlike Snort, where Snort basically are generated from the IP and so on. But indeed, those ones are automatically getting from the attributes, but in the, I would say, near future, we might get the...
Because with Snort and Suricata, it will get all the network attributes and it will generate Snort and Suricata rules. And in addition to that, you can also have custom crafted Snort and Suricata rules. You can create those as an attribute, and it will also include those appended to the list of generated rules. So yeah, indeed, we should have something similar for Yara as well.
For Snort and Suricata, you can have define a rule for various reasons. It's sometimes you might have modules in SourceFire, Snort, whatever, where you basically do specific pattern matching that you can generate from the current attribute that we have. So that's why you can add or complex rule set with regex and so on. Can be generated.
And also another interesting thing with Snort and Suricata is if you have some Snort rules already in the system, some crafted ones, it will convert it and optimize it for Suricata if you do Suricata exports.
Then you have others like you can get the tags if you are interested to how people classify information. Could be used for people that doesn't want to see TLP number information, they want to review it automatically, they can see the tag. Same with network activity, it's basically it's only network indicator that you can use for plugging your proxy logs or stuff like that. This one was a thing that we used a long time ago, but it's still working. It's basically you can copy a JSON object from one instance to the other. It tends to completely disappear and less used because now we have the local feature, so you can basically automatically synchronize. But it was used when you have kind of air-gapped MISP at some point. Create event is basically like indicate is to create an event. Same for update. You can want for upload a malware sample. So imagine that you have a specific event for a spam trap that you collect. You can use that one for adding your samples. Sightings is you have seen this nice Facebook OK button. You can basically do the update from the API. So you can set up. You just say okay. Sightings at IP 8.8.8.8, it will automatically update the sightings on all the MISP events and add new values. Usually what you do when, for example, you have a CM and this one do 2 or 3 map pattern matching and it's matching and then you return back the input into MISP. It's interesting too even for local MISP, if you want to know that your automatic system did the detections, so there you have an indicator, or you can add them.
About sightings, actually, so it's just saying that I've seen it at this time.
Yes.
That would be interesting to have a comment as well, by saying where I've seen it, or have I received the email,
Source.
or the source, or some comments.
Because right now the only thing you can specify is that you've seen it and when you've seen it.
Because we have a plan and this is an issue right now to have a negative sightings too, so that we don't like this. Things like it's incorrect or something like that. So it's a detections, but it's incorrect one, like false positive. But indeed, for the common source, could you check in the issue that we have? No, but we have one open for a negative one.
Oh, and just add it here?
Yeah. To keep it. In the web interface, we haven't looked into it, but we have tons of statistics of number of attribute, type of attribute, and so on, and you can get all those stats for from the API. So if you have your own graphical user interface, your Tableau, whatever thing that you use for doing analysis,
Does it contain the status of the MISP, like the running memory, CPU, or something like this?
No, it's not the monitoring part. It's obviously just the stat from the event, but not the monitoring. Okay. So you would like to have kind of monitoring of the MISP instance?
Just to make sure that, for example, the instance is still running live and stuff.
So the diagnostic page, but from the JSON.
Actually,
It's there?
I don't know if it's exposed to the API, but we have, for the diagnostics, we have settings, we have drop to JSON, so we could just expose that.
Okay. Because this one is not exposed.
Indeed.
Okay, great. So we have it, but when no one knows about it. Okay. Okay. So we have to display it somewhere. The last one is a very recent one, but we simplify. We try always to simplify as maximum. Nowadays, with MISP, when you add an attribute, you have a default category. Previously, you had to set up the category, then you had to set up the attribute. So we wanted something really simple. This Python script is basically you just set an attribute, so IP, source, destinations, and then automatically we set up the category for you. So usually it's a very quick way if you have a script and you want to add a lot of attributes to a specific event, you can use that one. You see it's 5 lines in Python, so it's straightforward to use. But the nice thing is this one relies on the default MISP behavior of categories and so on. So if you want to use it, it's traditional modules in Python. When you instantiate PyMISP, you have to pass on parameters, so URLs, API keys, so basically that's coming from the keys API, verify that. Then JSON, this one will be a hot topic.
I think it's removed already.
It's already removed. You can still set it up if you want, but we don't want to support anymore XML. It's still there, still supported, still working, but we want to depreciate the complete use of XML. Even if our XML was quite good and quite compact, in long term for the JSON is easier for us, and the standardization of the format is based on JSON, not anymore XML.
Well, basically, in MISP, whenever you're requesting an API, if you're really masochistic and want the XML versions, you can always just pass the content type to be XML, and then you get everything back in XML where you would get JSON. But generally, it's something that I don't think many people use anymore.
No.
So you're much safer using JSON.
We are still people using XML, and we are still all tools using XML on the background. So then you have tons of functions that are documented, and then you have a response containing errors, or basically it works. That's basically the generic way of doing it. So what can you do? Different capabilities, you have basically traditional one, get, add, update event, publish, delete, add, remove tag. So everything that you do from the interface is usually available. Then you have specific one where you can set the attribute as a parameters of the functions, as a function name, so the function name itself contains hashes and stuff like that. But now the recommended way is the one with the type, you just set the type and that's it, it's generic. We still keep it because it's basically initially the format of the library was done, but at some point it will disappear because it will be more easier.
Well, one of the things that you can also do is when you're adding an attribute by PyMISP, you're unsure about the category, you can use some same defaults, and also for the IDS flag and so on. So if you're not sure what you can do, you can add attributes by just saying type and value, and it will set everything up around that by itself.
Yeah. You can set an attribute, an email attribute, and stuff like that. You can upload the download samples of malware directly. You can manage a proposal through the PyMISP API. You can use the full text search like you do from the user interface. You can even get the event in sticks format, so from PyMISP. PyMISP has 3 tools now: OpenIOC, Sticks, and Neo4j. So it's quite recent, so what you can do is basically from a MISP event, you can convert it as a Neo4j object. So if you have a graph database, you can re-import it into your graph database. The sticks now is included by default in PyMISP too, and the same for the OpenIOC. So you can basically batch and process OpenIOC files directly from PyMISP. And then you have plenty of statistics and so on. One of the things that you have in the directory, you have in the example, a subdirectory called situation awareness, where we do plenty of experiments regarding visualization of information and so on. So you can see, for example, the kind of attributes that are used, the kind of indicators that are commonly shared and so on. It's quite handy to see what are the capabilities of some incident response team, because depending on the tools or depending on the attributes they share, you can deduce what kind of capabilities they have, which is quite interesting. Like for example, financial fraud, you see that for this kind of I don't know from which machine it's coming from, it's not very common because this one is more targeted reversals, where you see that it's more domain host names and hashes and so on. Then in the directory of example, we get one called feed generators, where you can generate your own OSINT feeds. So you have seen from the interface you can download OSINT feed, but you can generate those ones. So it's basically something like Taxi, but as simple as possible. So I don't know if someone of you have already used Taxi for information exchange. It's a pain in the ass, to be polite. With the OSINT feed, you can generate small files, bucket files, so files that are separated, and then you can create automatically this metadata. So it's basically a directory with metadata files and JSON files. All the OSINT feed is described like this, so you can create your own as you wish. So if we go to the next slide.
Back to Taxi, I don't know if you have seen, but basically, Software disappeared. And Anomaly just released Tax, which is a...
Yeah. I did some look at it.
Okay.
Carefully.
Okay. Okay.
So basically, it's what I understood from the software, because I don't know the software recipe to have a look at it. It's a kind of it's written in Python, and then it's a front end to their backend infrastructures. So it's basically a Postgres with full text and so on. But the connection and so on will be done by kind of cloud services behind the scene. I don't know what they support in Taxi at some point. If it's to the pub sub, just the inbox channel, it depends. Yeah, it's one of those many tools that exist. For Soltra, it's quite complex, I think, because it has been bought by NC4 nowadays. So, as I said, for some people came to us say, okay, we want to use MISP instead of Soltra because it disappeared. But what we ask is to extract files that they use, so that we can parse them, see what kind of format they look at. But it seems to be sometimes complex.
We could test it because we now also have a Taxi.
Yeah, the Taxi connector.
Yeah. So it's based on Yeti?
No, OpenTaxi.
OpenTaxi. So we have a Taxi module that is still pretty experimental.
Yeah, so see, you already have Taxi provider, you can use it. But it's still experimental, but if feedback is welcome too. Yes. Great, that's nice. So if you want to use a feed generator, you just have a configuration file. And it's all we generate if you go on the next one. So basically URLs where you get it from the tag. Then you have a filter, distribution level that you want. So how does it work? For example, the OSINT feed that we provide in MISP is generated from our own MISP. Then we have a tag called circle OSINT feed that automatically generates the feed. So it's just this script running, generating the OSINT feed into the URL, so the path. So like that, people can benefit from sharing between MISP without having any synchronization. Maybe you can go there.
Sure, yeah. And one of the advantages is that we try not to send the entire data in one package. So this feed that is generated is basically, Alexander should show it what it actually looks like.
So basically this is the default one. So if you look at this one, what is it? It's an SSL server where you have JSON files. You have one called manifested JSON. This one contains the description of each JSONs with the organization and so on, and you basically have the simple JSON files which contain the event. That's it. And it's full MISP. So the nice thing with that, you can browse those ones just like you were browsing a MISP remotely. But what you are browsing there is just the HTTP directory. So it's really, really simple.
So basically what it does here is it reads the manifest, and that contains all the event metadata that's in there, and if you click on each one of those, you can browse the individual events as you would in a normal event. And you can then cherry pick based on that.
We didn't enable it because it doesn't make any sense. So just for your information, it's because it's generating on this one. So if I'm taking the tag here, and then you see that we are quite
But isn't it just from enforcing them to
this one.
No?
It's very simple. Great.
So those have to be.
Yeah, sure. Sure. Wait. Too much tag.
Yeah, we need to search. Oh, it's not in the taxonomy.
No, because the default is
Okay.
so, and then, so like that you can see how it works. Those one are the stuff that we consider as being TLP-wide. And if you go over this one, well done. Then you see that this one is the tax circle OSM feed, which is generated from the Python script. So and you can play like this as you wish. You basically tag, generate your feed, synchronize with others, and do whatever you want. And it's very simple to do. It's just 2 lines of Python, and then you have the script behind. And then you can language the files or the event as you wish if you want to do more things. Same with OpenIUC. If you have OpenIUC's API to import the data and so on. MISP, the official repository of this one. We welcome pull requests. So the API is known to be quite stable. People are using it quite actively for various things, and we even use it for quite intensive tasks, and it's quite safe.
Yeah, and it's probably more stable than the built-in APIs in this. So even if I change any of the MISP APIs, the MISP one should stay the same. So it should make it easier to adopt for long-term use. Although we haven't really changed the APIs too much.
Yeah. Just a quick one, because we are already a bit over 5:30. I'm not sure how strict we are here. Don't forget, the conference is run by a policeman, so this one was an idea that we had. MISP is a platform where a lot of people are working, but you try to keep the stuff clean. So that means you have your event and so on. But when you are a security researcher, sometimes you want to take a bucket of events and start to dig into it, merge attackers, merge campaign, and so on. So one of the ideas was to build something from scratch, which is not relying on MISP in any way, except extracting the data from it. And the project is called MISP Workbench. But the idea was the following. We basically use MISP as a bootstrap, and then we start to make investigation and do malware clustering, malware classification, and so on from the dataset that we have, and find new correlation that MISP doesn't find. That's basically the idea there. The thing that at the same time we wanted to do it automatically, we have a lot of scripts doing lookups, analysis, and so on, but it needs to be very fast. So we designed some additional functionalities where we can do fast lookup with the event in MISP. At the same time, we include for the first time the Galaxy, which is the adversary group, the threat actor, and those ones are automatically generated based on keywords that is matching into a report text to automatically correlate all the group together, so the threat actors and so on. So adversary group is again simple JSON files. You have, for example, here Putter Panda, you might know this group. It has some synonyms because it would be easier to have always the same name, but no, it's not like this, so you have tons of names. Estimated country of origin, some reference, and that's basically it. So you basically have fast. Same for tools, Poison Ivy, you have a description, so where it's coming from, and that's value that you find in the report sometimes. You see those tags, like Poison Ivy mentioned in the report, but you want to automatically correlate those. So what we did is the following. We extract everything from MISP, type it into a fast lookup database, so we basically use Redis on the backend. I don't know if you know Redis.
It's a well-known database for fast lookup. Automatically we find all the groups, and every time we find a word, so for example here we have Codoso, which is another group, and you see all the events that are basically matching Codoso, either in command, either in a report, in text somewhere, in tags, whatever. And then you already do classifications. That's the first step. Then we extracted tons of things. As we have the sample associated, we extracted original file name, so the file name described in the PE, compilation timestamp, import hashes, a number of sections, the entry point, and so on. I think we already did the architecture course, but we are working on the other one right now. Then what happens is basically we get the sample, then we extract everything. You see that we have the entry point, the timestamp, you have, is it a PL file, because sometimes you have sample and PE files, the import hash, timestamp, and so on. If it's a file, it's packed on another packer that we know. Then, if you look at one value, we look at the compilation timestamp, and this one is quite interesting. We basically take all the samples, take the timestamp, this one is interesting, it's always fixed, hard-coded. We have a lot of frequency, and we see it on 25 unique events in MISP. So there we have a new way of correlating a lot of events that are basically something. Or for example, people forget to put the timestamp. That could happen. Rarely, but it happens. And we have others that are reappearing regularly. So now if you go back on that, next one, yeah. Compilation timestamp. This one is interesting. What we have seen is all these events are related to this one. And what you can see here, we see Winity, TV Spy, we see Hacking Team IOC, and so on. So it looks like someone is reusing a timestamp here. For example, by this kind of information, it's helping that, oh, maybe the FBI flash information that we receive contain imports from those ones, even if the hashes are not matching. It's basically a way to do new additional correlations. Then, the nice thing with this workbench, you can merge events. Say, okay, this correlation for us is fine. So we merge the event, and we know that this event will be merged as a standalone. Same one, original file name. Original file name is a file name that you find in the PE. And you see flash utils, for example, this one has been regularly used. A Juniper SSL VPN, and you see that you have unique event ID. Well, some. So people are reusing the same names. What is the reason behind? Some attackers are basically trying to trick whitelisting of some antiviruses and so on. For flash utils, it's always the case. WinRAR, Chrome, for example, is usually whitelisted by a lot of tools just by the original file name of the PE. Great. Not a very good security measure, but it seems to work. And if you go on the next one, you see that Chrome.exe, there's a group that is usually it's not really well known. You can look at reports that don't mention that. The Dukes, they're all using the same original file names, Chrome. It's quite interesting. We didn't know that at the beginning, so by doing the analysis, we discovered this. So it's quite, then you can merge events. You can say, okay, all those original file names have basically the same original file name and the same potential groups behind.
And just one thing is the merging here happens locally in memory, so you don't have to alter the data of other users and so on, you just play with it.
Yeah. So what we did too is, so if you go to the MISP workbench, it's 3 different modules, but one is the SSD clustering. So we try to cluster all the hashes from the binary, so it's a fuzzy hashing algorithm, to group samples by their similarities. And like that, you can find out if you have some groups that are matching the same similarities for the file. So if you have some sections that are similar, you might discover it. We discover some targeted impacted samples, so if you can go to the next one. This one is interesting. We have a group here. Again, we are back to the some interesting report here. We have, again, an API flash report, Black Vine, we see Noveta, and we see that, for example, those samples have some similarities. So having the expansion from MISP, it's allowed to the analyst to say, okay, maybe it's something else we need to start to work on. But it could work for any other event. You have, I don't know, malware sample coming from email that you receive, and if you want to find similarities, you run your similarities tools, you have your group SSD, and then you have all your events. This example is quite meaningful because basically you have already seen information, but if you have internal use case, it might work too. Same for the hash table.
Sorry, just explain.
Yeah.
Instead of merging the event, it would be interesting to create galaxies directly.
So these are only based on the, no, these ones are.
No.
Yeah, that's true.
Yeah, indeed.
Or tags at least.
Yeah, but in this case, it's a good point because attribution-wise is even more reliable because we have similar sample sets.
Yeah. So in the feedback loop, right?
Yes. And we generate the JSON for the galaxy and then we can cluster. And then as clustering, we use this element. So we can create the event automatically.
Sure.
Or
Oh, makes sense.
nice comment. Very interesting. Can you take one of that?
Yep.
Great, thanks. Same other problem that we have is when you have a huge data set, you want to have fast lookup. If you take 2 or 3 seconds for doing a lookup, you don't want to query MISP, do a TCP unshare, query the, and so on. So MISP store is a way to extract all the data set from MISP into a Nash database. So it's SHA-256, so it's pretty straightforward. But this data set will allow you to do lookups even on a compromised machine. Imagine that you have incident response, you do disk acquisitions, and you need to do fast lookup. You have your full hash table there, and you can do quickly your fast lookup without touching MISP. So the module itself, HashStore, is within MISP Workbench, but it works out of the box. So you just need to connect with the SQL database and then extract it. So it's a kind of Bloom filter, but the advantage here is just one-to-one mapping. For example, if you use FTK for doing the collection or the FFF or whatever, you just put your hashes and just find out. So it's basically in a workbench, and it's a subdirectory called HashStore, but it can work in standalone mode. So the idea behind was to build all those functionality into a single tools. It's kind of enrichment, but a bit more advanced, especially for the portable executable, because having enrichment on one side alone, okay, it's one thing, but having it automatically you see the correlation, it's more interesting. We try to have some simple connector. The group even using Galaxy is right now using full text, so all synonyms are used, and we don't have too much false positive. But if you have names that are very common and they are coming from the galaxies, you might get into some troubles. Yeah, it's standalone enough kind. You just need one connection to MISP one time and then that's it. How it works on the backends. So it's again full Python 3, so no Python 2. Redis backends, the full text indexer is called using Wash, it's a library in Python. We use PD file for the PD processing. We did some tests with Radari. It's some bugs, but it's maybe something that we need to work on. And then Flask and Bootstrap is used for the web interface, so it's really simple, no black magic here. The setup is easy. We export from MySQL to Redis. Is a full snapshot, and for the HashStore is a partial snapshot. Something that you have to take care of, that it doesn't respect any MISP API, so it's basically when you have database access, it's your MISP, you do whatever you want. Usually it makes sense, but it's something to keep in mind when you do it.
But generally, when you run your own instances, the data that you get, you have access to anyway, so that makes sense to do it.
So for full text, the correlation for SSDP is running in background, but we basically have a function that is highly distributed, so you can run a lot of SSD correlations on a single machine as long as you have a lot of processor. It's working quite well. So this setup can be run at regular intervals. It's not a one-shot. So basically, so if you're interested in if we have the MISP Workbench, MISP Galaxy, the data processing one was the old approach. There are still some tools there, and then the SSDC. It's a modified version for the SSD correlation, which is distributed and can run on multiple CPU. And as backend, use Redis instead of using a local memory point. That's basically it. And I think we are just in time. So I don't know if you have any questions, ideas, comments, or use case. That's great. I mean, in fraud detection and so on, I'm sure that there are other things that can be done. Because I'm talking about correlation of malware, but maybe at some point this could be used for fuzzy matching attribute too. It's something that we still wanted, but it's in the plan that we didn't do it. It's fuzzy correlations on attributes. When and I know in the banking sector we get the request. When you have mule accounts opening bank accounts, they tend to use the same name, and sometimes they have just a typo in the name. So one of the objectives at some point is to have a MISP way of doing correlation with specific algorithm. So instead of having a one-to-one correlation, you have kind of Levenstein-Dishton correlation where you basically have some one or two characters that changed and giving a probability of correlation. But for the use case that we have right now, one-to-one makes sense. Approximate or fuzzy matching is still for some advanced use case. Yeah.
So it's possible to add some samples, some binaries, to attach binaries to events, right?
Yeah.
What about doing this kind of like, so the MISP bench is pulling out those binaries and then running those PE curves to extract information, but what about doing this automatically when I attach, for instance, so there is this event, I attach the sample and then do all those static analysis and extract all those attributes automatically and add
We had some discussions about that already, that we need a hook for malware uploads, and the first use case for that was SSD tool, because right now what MISP does, it simply just hashes a sample and it gets MD5, SHA-1, SHA-256 when you enter a sample, and for anything else you need to trigger an enrichment. But indeed you want to have a hooking system for that, where you can run other
kind of restrictions.
Yeah, indeed.
And I think it's very nice, a good point because it's back to the hooking for modules.
Yeah,
So if we
yeah, indeed. So that will be a much more generic approach that we could do anyway.
Because the code base that we have there can be used for the modules.
I mean, we can always expose it. We can see what happens.
This use case was started with GData. Mario Machelek worked with us on this one, and she did a lot of blog posts about it. And it was coming from a dataset with GData and our dataset. But it was really an irregular case because it was the analysis that wanted to make a one-shot analysis and focus on a specific group of actors. But indeed, for the work for the hook, it's more at regular interval when you upload the samples. But we need to do it. Just for the ones that are deep into MISP, we do a hackathon next week in Zurich, which is remotely accessible too. So if you want to hack and work with us on some funky features, we have plenty of things like ranging from documentation that it's so fun to do, but some of the people really liked it. During the hackathon, we had people doing it. Up to things like new import-export modules and so on. One of the projects right now is to have a kind of better integration of MISP with other tools and to have kind of VM with all incident response team all together. So there's a tool that has been recently released called the Hive, which is quite interesting tool and supporting quite well MISP, so at least for import. Export will be supported soon as far as I know. And then to have such kind of VM where you have everything in a box. Maybe Viper could be the addition soon there. We have some other crazy projects like privacy preserving format, but that's already, there's already some prototypes. Ongoing up to running MISP on Raspberry Pi. Yeah.
On a cluster of Raspberry Pi.
On a cluster of Raspberry Pi for doing workbench with SSD. Yeah, why not? So that's basically. Anyway, thank you very much.
Thanks, guys.